Hello, wonderful people of the internet. Welcome back to another episode of Simuleo. So today we can just hammer out visualizations. I'm pretty sure we can just make everything that we need for the chapter today, and we can get this convolution chapter already all done and ready to go. Gibbous, hey, thanks for coming in, and anyone who might be lurking in chat, hey, thanks for being here. Again, today is kind of a working stream for the first 2 hours. Like I said before, I do generally think that we can knock out most of the convolution chapter. We just have to do it. And just, quit messing around with weird plotting details and just go. And I think we're ready to just start making visualizations. Hey, Amaris, how are you? After that, I'm not gonna lie, I am kind of keen to try another Guild Wars stream. I realize it's not everyone's, cup of tea. Some people don't like it, some people do, but I've been getting a lot of enjoyment out of the game recently, and I thought maybe you guys would too. I spent a little bit of time kind of setting the game up earlier today, such that, I don't have, I can have chat on screen at the same time as I play the game and stuff like that. There's a few small details dealing with how Guild Wars resizes the window and how it doesn't quite fit on my desktop and blah, 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 blah. But I think I got it all working now with some special OBS keybinds and all that kind of stuff. So it should be pretty good. I had to redo it's going to be a bit weird because I had to redo the interface a little bit inside Guild Wars as well. But yeah, we'll talk about that in a few hours. For now, let's talk about the convolution chapter. I have the chapter up. We've already read through the first bit here, and now we're talking about convolutions in 1D, and we basically got through the entire section, and we got to the point where we started to add the code in here, and that's where we left off yesterday. So today what I'm going to do is I'm actually going to update the convolutions code to make sure it looks good, and then from there I'm going to just put it in there, and then we're going to start on the next section, which is playing with filters and dealing with boundaries, and then periodic boundary conditions, and multiplication as a convolution. It sounds like a lot, but the truth is, there's just a lot to do in this chapter. Like, when I did this chapter before for, convolutions I made this chapter before, and people weren't happy with it, because they said I didn't go into enough detail. And look, there are still certain points in this chapter where I know I didn't go into enough detail. But all of those points I think I've highlighted, and I said we'll talk about this later, and I think what I am putting forward is genuinely one of the most approachable introductions to convolutions that I've seen online. We'll see how it's how it is interpreted. Some people might like it, some people might not like it, and that's totally fine. But I'm really doing my best to make sure that this chapter, makes sense pedagogically. It's the first chapter I'm putting out in 2020, and I really want to make sure that I want to be going at a breakneck pace. Okay, well, I don't want to literally break my necks, but you know what I mean. Like, I want to move at a pace where we're putting out content like every 2021. You're right. Sorry, did I say 2020? I meant 2021. But yeah, I really want to start putting out content as quickly as possible. So on that note, I'm actually going to go ahead and get started here. So we're going to cd into code. Tomate. Cd into code. L is here. CD into Julia, L is here. We shall not mention 2020 ever again. We will almost certainly mention 2020 a few times. It's a bad enough year that it warrants, at least some discussion outside. So I'm going to go ahead and just copy the convolution code we have from Convolutions in Simuleos and put it over here. CP project, Simuleos, Convolutions, and then conv.jl over here. Okay, so let me open up conv.jl. There's a lot of stuff here that we don't need, and so I'm just going to kind of remove all of that stuff we don't need. So, for example, we don't need FFTW, we don't need plots, we don't need linear algebra, any of that. So let me actually add FFTW, because we do actually need that. Okay, so we're going to remove this stuff. Again, this particular code is not plotting, so we're going to remove all this plotting stuff. All right. Here's the convolutional theorem. Let me come back to this, and I'll explain why I'm going to come back to this in just a bit. So we have convolution simple, and then we have the main in here. I'm going to come back to that as well a bit later. So right now I've got four different convolution functions. One, we have the convolution via the FFT, which is fine. It's an application of the convolutional theorem, and it works okay, as expected. So what I think I might rename this to is Convolutional Theorem, maybe, or something like that. But that'll be workshopped. I'll work on that a bit. Now, what I'm not happy with is the fact that we have two functions here, convolution simple and convolution linear. Now, convolution linear and convolution simple are identical with the exception of one thing, and that is that the length of the output signal is going to be the length of signal 1 plus the length of signal 2. Now, I'm going to have to mention a small caveat in the text here, saying that there's actually going to be something slightly different with this visualization here that I'm showing up here, and the code that we showed here. And that is that, again, the boundary conditions are slightly different here. So for the simple convolution, the linear convolution, we're just going to say the output filter is equal to n. And what I think I'm going to do is I'm just going to read in n. I think that's what I'm going to do. I'm going to change this to convolute, all right, signal 1, array signal 2, and it's going to be, yeah, we're going to output something. So we have signal 1, we have normalization factor. All of this we don't need. So let's go ahead and just remove that. And now in here, we're just going to say, 1 second, I need to think about what we're doing. Give me a second. N is what we're going to call it, but I think we should call it output size, maybe. And that's going to be, it doesn't matter. Let's just say output size here, okay? And then instead of using n in here, we're going to do output size. Actually, we don't need that anymore. So we're going to, oh, actually, let's just leave it in there, just because I'm going to use it later. So I'm going to kind of like rewrite the script right now, and then we're going to put it in there. So because we're reading an output size right now, we no longer need the simple convolution, because the only difference between the simple convolution and the previous convolution linear that we had was n. That was the only difference. The rest of it is identical. So that's why I didn't want two functions for that. So we're just going to remove all this guy in here. And there we go. So now the question is, what do we do with the periodic one? And I do feel like maybe for the periodic one, we, you see that there are 3 possible sizes for the convolution. There should, I only know of 2. Open here, paste. Parameters, returns, out, an ND array. Convolve, valid. Note the convolution operators flips the second array before sliding the 2 across another. So this one, the 2 arrays are the same length, so there's only one position where they completely overlap. Wait, what are they saying? 1 second. So they're saying the convolution operator flips the second array before sliding the 2 across another. That's fine. Only return the middle value. So it looks like there are only 2 possible options here. There's same and valid. And I don't know what the difference is between same and valid. But I guess you're right. Probably it shouldn't be convolute. It should probably be convolve. That's totally fair. In here, convolve. Okay. I'm not sure what to do with this one yet. We'll talk about that in a bit. I guess we should say, how about linear convolution? Is what we're going to call it. Linear convolution. Or maybe convolve linear. It doesn't really matter. And then up here, we're going to call it convolve cyclic. All right. It's up there in the description of the mode operator. Same returns an output length. Okay, so full. By default, mode full returns the convolution at each point of overlap with an output shape of n plus m minus 1. Yep, that's fine. Mode same returns the output of length max m n. Boundary effects are still visible. Valid. Mode valid returns the output of length max of mn minus min of mn plus 1. The convolution product is only given for points where the signal overlaps completely. Values outside the signal boundary have no effect. Okay, so I think the same, yeah, so I think we're going to deal with same and full in here. I mean, there's no reason to really follow the same semantics here, but actually I'm having a bit of trouble understanding what they mean by valid here. Mode valid returns output of length max of mn minus min of mn plus 1. The convolution product is only given for points where the signal overlap completely. Okay, I think I know what they're saying. So if we look at this visualization here, I think the only parts where they would output the convolution are going to be where the triangle and square are immediately overlapping. So that is just basically from here to there, like just from that bit. So I don't think we're going to implement that one. But I do think this split between cyclic and linear convolutions is worth doing. So I think that's probably fair. And then we also have the convolution FFT, which we'll use outside of that. So let's go ahead and remove this in here. Yep, that seems fine. Remove the plotting in here as well. And let's just mess around with these a bit in main just to make sure they work. So I don't know exactly what the convolution that we want to do in the end is, but I think the one that we're going to have them do for the tests will simply be the following. I think we'll do the random with the Gaussian distribution. Right, exactly. So I think having a cyclic and linear split is a good idea. There's a way to write this such that it's the same convolve function, but I don't think we want to write it that way. I think this is how we're going to do it, because again, we're trying to teach people how, if they were going to write this code, they would write this code. And I think that's important, you know? So we're going to DD here. That's also why you could argue that probably I shouldn't have this sum that we're adding together in here. Like, that's another thing that I probably shouldn't do, but we'll talk about that in a bit. So let's go ahead and get the main function done. And for the main function, I'm going to do a convolution with a set of random numbers. And I'm just going to do all three of them. So we have the Gaussian signal. So we have a random distribution in X. And the reason I'm doing it this way is because the convolution with a random distribution is the one that I think provides the most intuition for what the convolution is doing. It gives you the best expression of what's supposed to happen at the boundaries, and it's the easiest to test. So that's why I want to do this one. So now let's grab these two guys in here. Oop. Well, actually, let's just grab all four of these guys. Paste them down here. Remove these guys here. Remove that. XX. Remove some of these guys. We don't need to normalize in this case. And we can just check the output convolution in each case. And I suppose, you know, you can print them to file or do whatever you want to do, but that's okay. Also, another note, I changed my stream resolution back to 1920 by 1080, and I now have video quality options. So I'm pretty sure just yesterday's stream, there was just, I didn't have quality options because I wasn't streaming at the typical 16 by 9 resolution. I know that's kind of a random thing to talk about right now, but I just wanted to say that I was looking back at my previous VOD that I had yesterday, and I realized, like, even the VOD didn't have quality options. And usually the VOD does have quality options, even if the stream doesn't. So that was why I'm back to doing 19 or the 16 by 9 ratio. It doesn't matter for you guys. It just matters for me for setup. It just takes an extra like 30 seconds to set up every stream. But that's fine. That's what the starting screen where it's like, you know, Simuleos is starting soon. Like, that's what that's for, so that I can get it all set up and everything. So it's totally fine. Okay, so DD here. And I guess what we're going to do is we're just going to kind of do the convolution here. So Gaussian signals, and what I'm going to do here is I'm going to say setting signal to... Oh, wait a minute. I need to think about this. In fact, let's not do this part. It's easier for people, if they're trying to learn how to write the code, not to have to deal with this weird boundary thing where the Gaussian starts big on one side and ends big on the other side. No one cares about that when they're writing code. All we care about is getting a nice convolutional output every time. So what I might do, I need to think about a good test for this. Again, I like the random number test because you can just look at it and see if it's actually doing what you expect. So maybe what I ask them to do is just output the array in some sort of format that we can easily plot in new plot or something like that. And so, yeah, I think that's what we'll do here. So this is a set of linear convolutions, and let's just do it. So in here, we're going to say linear output. Output is going to be equal to convolve linear. And we're just going to read in signal 1, which is x, signal 2, which is y, and then the output size. So this is what we're going to say here. This is for, what am I going to say? It's for the case when we are outputting full convolution. So we'll say full linear output. Full convolution. Signal output will be the size of x plus y, right? So then it will be a length of x plus length of y. Okay, that'll work okay. So in here, I'm just going to change this to say full linear output. And now the next one we're going to say is, I suppose we want to do the case where, one second, I gotta think about this. So the next one we're gonna do is only output simple boundaries. Make n in convolve linear be output size. Make n in convolve linear. Yeah, I can do that. But also I was thinking of just changing it down here. So instead this is changed to output size. Because n is kind of a weird, like, why is it n? You know? So then in here it's again output size. And then I can just remove these guys in here. I mean, it's just one of those things, like, is there a reason that we call it n? I don't know. So I thought maybe just changing it to say output size would be a bit easier for people to read. I mean, like, I and j are loop indices, so I kind of think that's fine. But, you know, so simple boundaries, I'm just going to yank this, paste down here, and we're going to say simple linear output. You're going to involve linear, and this is just going to be the length of $, that, and there. And now we do a cyclic boundary. And then we're going to say cyclic, cyclic, come on, convolution. And we're just going to say cyclic output is going to be equal to convolve cyclic x and y. And that should be fine. Okay, so up here, we're going to say the boundaries. And again, I'm going to change this to say output size as well. Just because, again, I don't know, like, just making stuff up, you know? Did I call it cyclock? My bad. Thank you. Okay, so we're going to say undefined n, the output signal, donné. I think I can just remove that completely, and this would just be output size. And this is also output size. And I think what I need to do here is just put a comment in here saying output size will be set to the size of signal. Maybe it should be the size of the larger signal. I think, okay, we're gonna have to, don't forget the mod 1s. Wait, what's wrong with the mod 1s? Sorry, I feel like now I'm a bit... Oh, the mod 1s. I understand now. Oh, that's not going to fit, is it? See, that's why n would be useful. And of course, it shouldn't be the size of... And of course, it should be the size of the larger signal. Should it, though? Because the way that we're doing this is we're assuming that signal 2 is always a filter. And there's kind of an implicit assumption that the filter is smaller than the signal. But let's just see what happens. Oh, that's some ugly code, ain't it? If I change it back to n, we don't have this issue where it becomes too long on the, like, too many columns. But let's deal with the cyclic convolution when we get there. We're just writing code that works now, and then we'll kind of output it. So we have everything here, and so what I want to do now is just say for I is equal to... I gotta think about this really quick. I was gonna output everything to file, but I just realized that the full linear output, the simple linear output, and the cyclic output all have different sizes. So what I might do is I might just output multiple different files. Convolution is commutative. Let's just see if the code works that way. Okay, so the convolve linear function in here, and we're gonna say the output. Yeah, okay, that's fair. So here we're gonna say output array, output for convolution. This is the convolutional output. I know it says out, and people can already assume it's a convolutional out, but I just want to make sure I say convolution here. And I suppose up here then, what we want to do is we're just going to see if this works. So the length of max, so this is going to be equal to max of length of signal 1, length of signal 2. All right, let's just see if that actually works as intended. And again, this is going to say convolutional output. Output, and I think just to be consistent, we're going to do that. And in here, we're going to say using the convolutional theorem. Let's go down here and make it so these are just arrays, not a float 64-1. Although in principle, maybe I should make them all arrays of number 1. Maybe. Yeah, maybe I should make them all arrays of number 1. Just so it's clear, you know? I think this will work, but I'm just making it up. Paste that there. This there, move output size to the next line. All right. I'm going to do the lab for my networking class. This may take me offline. All right, good luck, man. I know that you've been kind of stressing a bit about the course, so, I mean, do whatever you need to do to, get it done, you know? Can you do something array number? Well, the 1 is the important part. Because, for example, in Julia, you can accidentally make a 2-dimensional array just by doing something like this, x is equal to 1, 2, 3. And this is now a 2-by-1 array, when you actually meant to do x is equal to 1, 2, 3, right? And this one would be the 1D array. And that's the one that you want to input. But this one is the 2D array. And would have a different convolution, right? So that's why I wanted the 1 there. So now I'm just going to output. I'm just going to output these all to separate files. Outputting convolution, convolutions to different files for plotting in external code. Just for the convolutional theorem one, though. Yes, I could, I think. Yep, I can. Nice. In fact, yeah, that'll be fine. So let's just go ahead and output them, and I think I can just use delimited files. So in here, we're going to do using delimited files, I believe will work. And then I can just do write DLM or DLM write. I'm not exactly sure. So what I'm going to do is I'm going to write and quit in here. And I'm going to actually open it up on this side. So we're going to cd into projects, algorithm archive, contents, convolutions, code. And over here, cd projects, algorithm archive, contents, convolutions, code. ls here, ls here. Okay, now we are still going to have to add 2D convolutions, which is probably going to be in the same file, but we're just going to get the 1D stuff done, and then assume that the 2D stuff is going to be added in. Oh, actually, you know, we probably want the 2D convolution to be in a separate file from the 1D convolution, because it is technically another section, right? So because of that, I'm fairly confident we do want it to be in a separate chapter. Okay, let me just run Julia, and let me just do using delimited files. Yeah, right, and I think it's right DLM. It is, okay. So, and then I believe, just to make sure I'm doing this right, x is going to be equal to, again, 1, 2, 3. And now we're going to do right DLM, and I think check dot text or something like that. Doesn't really matter. X. That worked. Good. So VI convolution. And actually, let's move it to see Julia. See conv.jl into 1D convolution.jl. Sorry, CP, actually MV. All right, let's go into VI 1D convolution.jl. And let's just output these guys. So we're going to do a DLM, write DLM. And we're just going to write them all out. So we're going to say full linear dot text. And this is just going to read full linear output. And then we're going to do the same for simple linear output over here. And this should be cyclic. Yeah. Okay, did it again. I don't know why. Let's try that again. All right. DTO cyclic. Why? Why do I keep writing cycloc? Is there a reason? Okay, so in principle, this should run. If I just go over here and I run include, and then we just do, I believe, just 1D convolution.jl. Okay, and I run main. This should output no method mentioned convolve linear array float 64 1 array float 64 in 64. Convolve linear array number. Okay, that's kind of what I expected. So, well, what I should have expected. So because these are arrays of number 1, what I actually want to do is say array t and array t in here. And I'm just going to change these all to array t. And then I'm just going to say where t is within the set of numbers. So in here, we're going to do dt here, t, dt here, t, and then we're going to say where t, t is within number, and we're just going to do that with all these guys. I screwed up, 1 second. Up here, I forgot the t, and this is where Julia's syntax gets kind of ugly, but that's okay. And then in here, we're going to say where t. I did it wrong again. 1 second, I forgot the colon. Go there, and then this should work down here as well. Okay, we're going to try it again, and try running main. Error out convolution not defined. This is going to be on line 78. Return out Okay, ran. So now let's see what we have here. Quit ls, and we should have check.text, so we can remove that. And let me just run GNU plot, and let me just try plot cyclic.text. And is that what I expected? Maybe not. Let's try linear, a full linear. Okay, and now we're going to do simple linear. Okay, good news. I think simple linear and full linear are correct. I'm going to run it again, and we're going to just take a look at this really quick. Because, okay, it's going up and down a bit more than I was anticipating, which is why I'm kind of a bit sketched out by it. So let me just do convolution.jl. And what do we have for y? So y here is going to be I minus 50 over 100 squared. Let me just output the random distributions as well. So we're going to do, in here, we're going to output that and dt there and there. And we're just going to do x dot text and x here, and then y dot text and y here. Oh, over here we're going to include again. Oh, include again. Run main. Okay, and now we're going to do quit. And we're just going to plot things on top of each other and see what we get. So now we're going to do GNU plot, and we're going to plot cyclic.text. And now we're going to plot replot on top of that x.text. And replot on top of that y.text. Okay. The convolution is quite high. So again, maybe what I should do is normalize everything and do this one more time. Yeah, let's do that. 1D convolution. So I think if we just run normalize on x and y. And y. Try that again. Include. Now we're going to run main. Normalize because I have to do using linear algebra. Okay, so now we're going to do this. Include main. All right, let's see what that does. GNU plot, and let's just plot with lines. All right, so there's this guy. And now we're going to try plotting on top of that y with lines. And now we want to do x with lines. You guys, you're right. You're right. This actually looks fine. The reason it looks fine is because the reason it looks fine is that when we initially plotted cyclic.text, for example, so when we plotted this guy, the original plot didn't go down to, here, let me just plot again. So this doesn't go down to 0. So it actually looks pretty good. It just didn't drop all the way down to 0. So that was why it looked kind of funky. So, okay, I'm happy enough with that. Let's just try cyclic.text. And then let's also plot full linear.text and replot on top of there. Oh, that's because I'm dumb. There we go. Okay. And now we're going to do simple linear.text. Let me just mess it. That was a mistake. Put this over here. Try that again. Make this huge. 1 second. Oh, I see what happened. Move this over just a hair. There we go. Okay. CD project, algorithm archive, contents, convolutions, ls, cd into code, Julia, ls here, vi, actually, GNU plot. Now we're going to plot simple linear.text. Okay. Now we're going to do full linear.text with lines. And now we're going to do simple linear.text on top of that. Okay, so these guys match up. So this kind of goes all the way up here. That's what you expect. It's cut off at the end there. Yeah, this one actually looks fine. So now the next thing I want to do is plot on top of this. So we're going to replot cyclic.text with lines. Okay, yeah, and see how these guys match up over here, although they are off by a single element, which is a bit disconcerting. Oh, okay, no. It's okay to be off by a bit because it wraps around, so it would be wrapping around at that point. But you get kind of a similar feature, but the tail of the Gaussian is still changing it slightly, and that should be fine. So it matches up at the end here. as it should. It should match up at the end because that's the point where the Gaussian is all the way back around. And so it should be at the same point here. Yeah. Okay, good. This at least makes logical sense. It's all working the way it should. Good, great. Let's do Control D, vi1d convolution.jl. And I'm gonna say in here, we do normalize in here. So here we're just gonna say normalizing the filters. Normalization is not strictly necessary, but good practice. Okay, so let's go back up and take a look at the code really quick. Oh, there's one more thing we have to do is the convolution FFT. So what I'm going to do is down here, we're going to say FFT convolution. So FFT, FFT output. And what did I call it? I called it convolution FFT. Let's just call it convolve FFT. That should do it. Great. G. And this should take the same thing as before. So FFT output is going to be equal to convolve FFT. And here we're going to take in X and Y. And this should be identical, but maybe shifted to the cyclic convolution that we had before. Oh, great. Thank you so much for following. Really appreciate it. Also, I'm realizing that, again, today's another kind of chill day. So if you guys have any comments, questions, concerns, ideas, anything like that, just feel free to let me know. And I'll do what I can to answer it as soon as I see it in chat. Cyclic convolution via the convolutional theorem. Okay, and here we're going to do yank paste. Oh, yank paste. And we're going to call it fft.text. And then FFT output. Okay, write this, go over here, include main, and we should have some stuff to compare. We're going to quit there, and now we're just going to go into, gotta think about this really quick, GNU plot, and we're just going to plot, I want to do plot cyclic.text with lines, and then I also want to plot fft.text with lines. Okay, look, I mean, it's off by like one element, you know, like that tells me that we're doing the cyclic convolution right. Again, we're shifted by one element, but like, that's good. So I'm happy with that. It means the convolutions are about what you expect, right? With the boundary conditions, they seem to be working correctly. The cyclic convolution is the same as the FFT. Let's go into the code one more time and see if we want to, yeah. So we're just gonna call it fft.text. And I think this is some decent enough code for a first attempt at putting it into the algorithm archive. Nice. All right. I'm really excited that we're getting this chapter done. Yeah, like pretty excited that we're finally wrapping up the chapter. I think it's turning out really well as well. Okay, so cd back a couple directories, vi1d 1d.md. Okay, so now we're at the add code section. Now the question is, do I have any other code already in? No, I don't. Do I have code in any of the sections? I do in this section. So let's go ahead and quit here. Vi convolutional theorem, and then convolutional theorem.md. Look for, I think there's like a method in here. Here. So wait, where are these other languages that I supposedly have? So if I go to Python, yeah, there's nothing in there because those don't exist because I had to delete them because, yeah, okay, let's just add this in there and let's just pretend this actually works. So let's go back over here. So the FFT one, I believe, is just going to be 1, 2, 3, 4 lines in here. So set number is just going to be on lines 5 to 8. So that should be here, 5 to 8. And we're going to write that, and that should fix the code over there on the other side. If we refresh the page, or does that not? Does it need to be? Okay, we're going to have to like refresh more than that, but that's okay. So let's go here. I'm going to have to rebuild the algorithm archive. So let's just grab this method thing, go back into the 1D, and where we do code in here, we're just going to add in that method right there. Hey, Doname, do you have any issues with Qt browsers? I'm planning to switch to Qt browser. I haven't had too many issues with it. The only issue I've had is that the ad blocker doesn't work, and you know, for some people that's a big deal. For other people, it's not a big deal. It's just that it works in weird cases. Like sometimes I'll see an ad and I'm like, I actually want to click on that ad, and then I'll click on the ad and I can't quite click on certain ads for some reason. Like, for example, the other day we were shopping for something, and as I was searching, whatever, DuckDuckGo or Google, there was an ad that appeared. So I was like, great, let's take a look at this ad. Because it actually looked like exactly what I wanted, but I couldn't open it up in the browser. And so that's, the ad blocking is kind of weird in some cases. It doesn't really do a good job, but that's really my only complaint. Overall, I really like how the browser feels when you're just like, you know, like, using it. Let me just do a new line here and remove that line there. And let's do the same thing here. New line here, DD there. Okay, so I think this will be fine. So we're going to do 35 to 54. 35 to 54. Okay. I love to customize Qt browser. It's like Emacs in this respect. That's fair as well. I don't really know all of the customizations to it. I just use it a bit, you know? As a note here, the code is we have written for this part of the chapter requires the user to read in what they expect the output array length to be. We will be discussing boundary conditions a little later in the chapter. Okay, so if we were to extend this, if we were to extend the convolution, as well, okay. Okay, I'm just going to say the code we've written here is that, and then finally, as an important note, let's see, if we were to extend this extend the convolution, hey Cropib, how are you, into continuous space, we might write something like this. Okay, so this should work. Let's go back to the 1D here. So let's see, we've got the two signals. We should have the code should be there. Maybe I have to, let's just rebuild the algorithm archive really quick and see what that does. And that should have the code, and that means our first section is basically done. And now we move on to the next section where we're playing with filters, doing some more animations and stuff like that. And we'll just see where it goes, you know? So yeah, let me get a little bit more water. I've been working on this chapter for way too long at this point, and I do kind of apologize for it. Like, I know this, it just takes a while. Like, that's just what happens. So here's the code. Donné. You kidding me? Am I just dumb? Oh, I am dumb. It's 1D convolution.jl. I see. Because I changed the name. 1D convolution. And so that should be correct, I believe. Yeah, there we go. Convolution linear. And let's just go forward a few pages. All right, that looks good to me. All right, so that means we've got the code. We have most of the discussion that we need. I think that's pretty good. So I think we're on to the next section now. The code we've written for this part of the chapter requires the user to read in what they expect for the output. Well, instead of read in, let me change that to specify. Yeah. Read in, and we're going to say specify what they expect the output array length to be. And that should be great. So it's output size. Good. Okay. So now we're on to playing with filters. Pretty excited for this. And we'll see where it goes. Again, it is a quiet day, so if you guys have anything specific that you want to talk about, any questions you want to ask, just feel free to do so. And I will, yeah, I'll do what I can to answer it as soon as I see it in chat. I'm hoping everyone's having a wonderful day and, you know, not too worried about life or whatever is going on. Okay. So playing with filters. Honestly, the best way to learn how convolutions work is by seeing them in use. is by using them for a number of different signals and filters. Let's see. Is by using them for a number of different signals and filters. So let us extend the example of the previous example. With a triangle filter. The previous example of a triangle filter. The previous triangle filter a bit further by convolving a square wave with a relatively sharp Gaussian, which can be seen in the following animation. So this will be the same thing, just with a very sharp animation, as we had before. And so we should basically get the same visualization. Yeah, like almost identical visualization. And that's what we're looking for. So let's go ahead and create that right now. So I'm going to have to CD into the appropriate directory. I think I can just do write and quit should be fine. So we're going to CD projects, Simuleos, and then Convolutions. Okay, Control D, CD projects, CD projects, Simuleos, Convolutions. And let's just go into Julia. So running Julia over here, let's go into vi-conv.jl. And I'm just going to run basically the same visualization we had last time, which is just a square wave. Except in this case, instead of doing the triangle wave in here, we're just going to do a sharp Gaussian here. And this is just going to be over 10 maybe. Well, let's make it over 20. Okay, so we're going to include this guy. Include should be conv.jl, and then if we run main, give it a second to build everything so we can make all the plots and stuff, we should be able to get a super simple plot with the convolution and everything working pretty well. Okay, so we have that. Let's just run main, and we should get some plots out that we can look at. Yeah, again, if you guys have any comments, questions, concerns, anything like that, just let me know, and I'll totally address it as soon as I see it in chat. Okay, let's go here. Quit, and now let's just open up the last. I think I can just do Mirage. I cannot. Okay, so Mirage out this.png. Okay, that Gaussian's a bit sharper than I thought it was. Yeah, right. Okay, so that right. Okay. Cool. Okay. Let me see. Let's figure out what happened. So the Gaussian was split in two because I don't know. We'll figure that out. Okay. The conv.jl G down here, and it looks to me like it's okay. Hey, Cropeb. Why are there two of them? It just got split in two for some reason. I'm not exactly sure why. I'm gonna guess that's because this needs to go to 1,000, and this should go to 200. So let's go here, include, and try that again, and see what happens there. We're just doing some convolution visualizations today. So let's do Mirage, there, and that one should be okay. Okay, well, right, it's close. That's not the visualization I wanted. So I just need to move the Gaussian over a bit, but you know, it's fine. Like, I just have to make the Gaussian actually start where it's supposed to start, which is here, not in the middle. But yeah, it's basically there. I think. Yeah, it's basically there. Okay, so why didn't this work? So here's our Gaussian, and then do I have Y defined somewhere else somehow? No, I've commented out all the other Y's. Let me comment out this line. Include main. Give it a second. Mirage. Did that one work? Almost. Well, I don't I don't fully understand how we're off by what's going on. So we have the convolution for some reason is starting there, or like the Gaussian is starting there, and then it's, I mean, look, the visualization is kind of what I wanted to see. but I don't understand why it's like not, okay, that's fine. I minus 500, not I minus 50. Ah, correct. Thank you. Thank you for correcting me. Try that again, and this should be right. Perfect. Ah, no, it's still not going to be right, because now the Gaussian starts at the wrong spot, so now we have to do the VCAT. All right, this is me being dumb. That's fine. Done. All right, so now we should have the correct visualization. We can just turn that into the animation we need for the algorithm archive. So let's take a look there. Mirage. Okay, again, right, because we started at step 10. It goes up. Wonderful. Goes back down. Okay. Yeah, that's what I wanted to see. A relatively sharp Gaussian. It looks good to me. And then it stops there. Cool. So let's turn this into our animation, and let's put that in. So we should have in the history, grep. Thanks, by the way. FFmpeg. And I believe we can just run basically 462. So let's grab that, and we're just going to change this to out24. Okay, and let's move that over here. So the animation we're going to want to add in is going to be out24. We're going to have to move that over. Right, I really like this, how this chapter is turning out, by the way. I think it's just turning out like really well. And look, I realize that, you know, like there's going to be some issues. As there always will be issues. But like, you know, as you know, the first thing that we're putting into the algorithm archive for this year, I'm relatively happy that it's this. Do you know C++? Yeah, I know C++. I did my entire PhD thesis writing C++. Now, if you're asking, am I good at C++? The answer is by public approval, no. My C++ is basically C code with additional features associated with it. So if you looked at all my CUDA code, again, I'm not going to pretend the CUDA code was good CUDA code, but it was CUDA code and it worked and it was in C++. So, you know, like, to each their own. So right now, so I just finished working at MIT. So I was doing I did scientific computing and stuff like that. That was my job. Anybody really good at C++ anyway? That's my opinion as well. I feel like most people don't actually know, like, I'm not saying they don't know C++, but I'm saying that there's always going to be someone else in the room who knows more C++ than you, no matter how much C++ you know. You know, it will always feel like, I don't know if I'm saying this exactly right, but when it comes to C++ 11, they added a bunch of features like vectors and stuff like that. That was super nice, you know, really incredibly useful. But then you get into like the C++ 14 meta-templated, it's hard. Like at some point, C++ code became functional. And when it became a functional like language, for me, it became very difficult to understand. Which is why currently we have like basically no C++ code in the algorithm archive. Because every single time we get a C++ review, people bicker about it so much. Do you currently have a job? Because I own a video game development company that's looking for a C++ programmer. Is this something you'd be interested in? I'm not particularly interested, but I do appreciate the offer. I'm sure maybe other people would be. I'm not really that into video game development as a like career path. So right now I'm kind of set. For at least the next few months, I'll be contracted. Well, okay, I can't tell you guys what my job is yet because I haven't yet signed the contract, but I promise it's actually really cool. You guys are going to be really blown away by it. I'm 90% sure you guys are going to love the idea. But again, I just can't talk about it yet because I have not officially signed any paperwork, and I need to actually contact my new employer and get them to you know, talk about the paperwork. I think it's just because the other gal knows things you don't know. Right, that's true, right? Like, I'm not going to sit here and pretend that the code that I wrote works and is as fast as any code in C++ can be written for my particular project, right? I know how to deal with memory. I know how to deal with GPU architecture. So when it comes to writing fast code on the GPU, I can do that. Now, is it good looking code? Maybe not. Is it, you know, completed the lab? Dude, good work. I know that you were stressing about it, so I'm really happy to hear that you're making progress, you know? Okay, so we've got the animation. Let's go ahead and copy that over. I'm going to open up a new terminal because, you know, when life gives you lemons, the appropriate response is just to open up a new terminal. I guess. Okay, that didn't make any sense. I'm so sorry. Anyway, we're going to CD into projects, algorithm archive, contents, convolutions, CD into resources, ls here. And I'm just going to CP projects, simuleos. What am I doing with my life? Simuleos, output, what did I call it? 24? Yeah, I called it 24. Out 24 convolutions. Out 24 .mp4. And we're going to call it 1D. I'm actually going to call it 1D Gaussian animation. Gaussian animation. And we're going to say 1D. What is my 1D Gaussian animation? Is it this one? Maybe I don't need that anymore. I think in the current chapter I don't see the 1D. Let's see. I'm going to take this week's quiz now, which is the last of this week's tasks. Since it's a closed book quiz, I'll have to turn off the stream for a bit. So you guys have a wonderful time taking the test or the quiz. I hope it goes well. And yeah, I'll see you in a few, I don't know, like whenever you come back, either later today, tomorrow, whenever you come back. See you around. Good luck. Blue Spider Monkey 2, thank you so much for following. Really appreciate it. Okay. So I am actually going to call this 1D Gaussian animation.mp4. That's what I'm going to call it. Now you guys are going to make fun of me for that name, and that's totally fair because it's a dumb name, but that's what I called it. And just, you know, I'm sorry. So we're going to do 1, 2, 3, 4, 5, 6, yank, 6, yank, move down here. And we're just going to do add animation. Perfect. Paste in there. And I called it 1D Gaussian, animation. Animation is redundant. Let me just move 1D Gaussian animation into 1D Gaussian without the animation. .mp4. Okay, so now we're going to do 1D Gaussian.mp4. .mp4. And that should basically put the video up. We're going to have to... I think we're going to have to rebuild this, so let's just run it one more time. And then when we rebuild it, we should be able to refresh, and there should be a new video available for that animation up here. Okay, great. So we're making progress, guys. It's taken a while, but we are slowly getting there. And again, I really do think that this chapter is one of the best chapters that I've written in the algorithm archive. Really excited for it. Probably more excited than I should be. Refresh. Okay, so now we have that animation, and we should see a new animation down here, which is the one for the Gaussian, and it goes up, and it goes back down. Okay, so playing with filters. Honestly, the best way to learn how convolutions work is by using them for a number of different signals and filters. So let's extend the previous triangle filter a bit further by convolving a square wave with a relatively sharp Gaussian, which can be seen in the following animation. Note that the final convolved image looks a lot like the square, except that its boundaries have been smoothed or blurred. Now, I want to take a look at this as well and see what the difference is. So this goes up and it goes back down. So in here I want to say, in practice, the operation here, the convolution, null output is very similar to the triangle wave. However, it's a bit, triangle wave before. In some sense, any operation, any filter, any positive filter, we'll say purely fully positive filter, will, let's see, in some sense, any fully positive filter will end up looking, I don't know how to put this. I'm not going to say, in some sense, the operation is the same. let's see. I'm just going to do this. The final convolved image looks a lot like the square, except that its boundaries have been smoothed or blurred. In practice, whenever a Gaussian filter is used, it will always blur the other convolved signal, which is why a convolution with a Gaussian is also called a blurring operation. This operation is used very often when dealing with two-dimensional images, and we will discuss common filters found in the wild in the next section on convolutions of images. Here, let me just make sure that link actually works. Down here. It does. Perfect. Still, it is interesting to see the blurring operation in action by convolving a random distribution with a larger Gaussian filter. All right, here's the random distribution one. I don't know why I like this animation so much, but I very much enjoy this animation, the one that I'm gonna do right now. So we're gonna say this, that, and change this to a random distribution. Comment that out, write this, and now we should be able to include and then run main, but I have to do one more thing, change this to that. Okay, so we're gonna run main here. Okay, so now include, now we're run main again, and then we should have all the visualization that we need. And then we should have the, we should have the random distribution one in the bag. So now we're going to do Mirage, out. Okay, this one looks a bit different, but no, actually it looks the same. Yeah, that one's nice. Okay, so there's that visualization. Again, it's just a random distribution, and you can see that it's just smearing it out. I quite like this one. I think it's, I mean, it does exactly what you expect, but I think it's just, I don't know. I just like it for some reason. So quit here. Let's go here, and we're going to change this to out 25. I need to change this to 5, remove the 0 there. And now we're just going to copy that over here. So I'm going to CP, and it's out 25.mp4, and we're going to call it, 1D Gaussian, 1D MP4, 1D random Gaussian, I guess. And then here is going to be out 25.mp4. Go back over here, and let's just grab the animation. So it should be yank 6 yank. Paste it down here. Okay, DD there, and change this to 1D rand Gaussian .mp4. So that should be that animation in there. Let's see. So finally, let's extend this concept to one final example of a square wave convolved with a triangular sawtooth function that looks like this. Okay, so now we just have to basically output the sawtooth function, and then we can work on the boundary conditions. I mean, we're really sweeping through this. Like we're very close to being done with this chapter. I think we can get it done in the next, like, I don't know. I think we can get it done in the next like hour or two, maybe hour and a half. But I'm going to be right back. So let me just, this animation we just made, I'm just going to have that MPV out 25.mp4 loop 0. I'm going to have this playing. I'm going to be right back, guys. Sorry about that. Give me just a minute. I'm going to get some water. And yeah, I'll be back in just 20 to 5, I don't know, like a minute. So be right back. Okay, back. Sorry about that, guys. So we should be able to knock out this chapter in the next hour. Pass the quiz. Good job, man. I'm happy to hear that. Okay. Let me just put on my little weird hobo gloves. And 1 second. Okay. So now we can keep going. I'll close that here. First time in the channel. I can't appreciate what you are covering here, as I'm not super familiar with convolutions and Gaussian equations, but it's interesting and you are presenting it in a great way. Thank you for this, all on stream. Yeah, so let me just talk about what that animation was that we just saw, because I do realize that today I kind of just hopped into it and I didn't really, talk about it too much as to what we're doing. So, and I think the reason for that was because I was kind of reading through the chapter and I was hoping that the chapter would kind of explain what it is that we're doing. But I realized that we also started the chapter kind of in media res, so it was kind of in the middle of things. What you're looking at here is a visualization of the convolution operation. So what's happening is essentially we have this Gaussian filter that's moving across this random signal. At every time point, we're multiplying the filter by the signal to get this kind of like green thing in here, right? And then we integrate the green thing to get essentially this dot on the purple line, and we move this across, right? And so what's happening is this output here is kind of a blurred version of the input signal, right? So this input signal is this blue squiggly line, and the output is going to be this purple line in here. So what we're doing is we're kind of mixing the two signals together, and this way in which we're mixing it is the convolution. It's really important for like a huge number of different things, like, neural networks have convolutional neural networks. You have convolutions used in just an insane number of places. Like image processing uses convolutions all the time. Integer multiplication, convolutions, they're everywhere. Solving partial differential equations, again, convolutions, they're everywhere. And so because of that, it's kind of a very essential operation that a lot of people get really confused about when they have to learn about it for the first time. And so that's kind of why we're doing this here, with the hope that we can really teach it in a way that's intuitive, and I'm doing the best I can. But of course, it's kind of a working stream, right? So it is hard to just jump in, and that is actually a recurring problem with my stream. It's hard to just jump in because I'm doing a lot of what is considered to be highly technical content. Curtis, by the way, Curtis, right? Thank you so much for following. Really appreciate it. Now I'm going to kick back with some Ocarina of Time randomizer. Let's see what's defined in the water temple. Dude, that sounds super fun. I'm glad you're enjoying your time. Okay, so we have the 1D Gaussian in here. We have the next visualization in there. And so we can just knock out the next bit. Okay, and I do need to, after talking about this, in this animation, it is clear, the final convolution is only marginally related to the input signal, the input signal. The final, in this animation, oh man, the final convolution is so blurred that it is only marginally related. Well, we'll say only slightly related. Slightly related to the random input signal. I see, so this allows us to have an output that is relatively consistent when compared to the potential input. Yeah, that's one way to do it, but also, like, for example, with this triangle wave in here, you can also use convolutions for like edge detection and stuff like that. It really depends on what filter you read in. If you read in, a Gaussian like filter, you get something that's kind of blurring. But if you read in something that goes like -1, 0, +1, so it's like goes down and then up again, in that case, you actually will get kind of a naive edge detection and stuff like that. So there's a bunch of different things you can do. It's just blurring is the most common one. We'll be doing convolution with a sinc function. I think a convolution with a sinc function. Oh, that would be interesting. Yeah, I'm not really sure what that would do. But we can do that a bit later. Or now, maybe? I can see what that looks like. But let me finish up this section of the chapter, and then maybe if we have some time at the end of stream, we can do that. I'm really keen to just get this through. Oh, it's just a low pass filter. That's really cool. I didn't put 2 and 2 together, but I'm happy to hear that. Like there is some intuition there. So in this animation, the final convolution is so blurred that it's only slightly, it seems only slightly related to the random input signal. In fact, when compared to the Gaussian, the previous Gaussian visualization, and the triangle wave seems this visualization this animation seems much more blurry, we'll say, or seems to average much more when compared to the previous Gaussian and triangle wave visualizations. And we'll say animations. Does that actually read okay? In this animation, the final convolution is so blurred that it seems only slightly related to the random input signal. In fact, this animation seems to average much more when compared to the previous Gaussian and the triangle wave animations. Actually, a sinc function would fit better for the convolutional theorem since the Fourier transform is just a rectangle. Ah, that's fair as well. We're not going to talk too much about the convolutional theorem this time. That's actually something I wanted to cover next time. But that's actually a good thing to note, because I think that's actually quite, it's useful. So in this animation, the final convolution is so blurred that it only seems slightly related to the random input signal. In fact, this animation seems to average much more when compared to the previous Gaussian and triangle wave animations. This is because the Gaussian is wider than the previous two filters. In general, the wider the filter, the stronger the blurring effect. I just wanted to make sure I said that, and also I did talk about bounds before. What? We'll be discussing boundary conditions later in this chapter. For now, wait, what did I say here? The code we have written for this part of the chapter requires the user to specify what they expect the output array length to be. We'll say, in contrast to the animation, where the filter cycles, continuously reappears on the left edge of the screen, we'll say. The code we've written for this part of the chapter requires the user to specify what they expect the output array length to be. So let's see. In this case, right, I guess what I'm trying to say is I am kind of pulling a little bit of wool over everyone's eyes, right? Because like I'm showing them this animation here, and this animation here is a cyclic convolution, right? But then I give them code for a linear convolution, right? And so I want to just very quickly say, in contrast to the animation where the filter continuously reappears on the left edge of the screen, I wrote screed, which is not a word. The code we've written for this part of the chapter requires the user to specify what they expect the output array length to be. The question determining what should happen at the edges of the convolution is a somewhat hotly debated topic, and does not and differs depending on what the screed is actually a word. It means extremely emotional and unhinged rant. For instance, you might be seen making a screed about MATLAB. Totally fair. Determining what should happen to the edges of the convolution is a somewhat hotly debated topic and differs depending on what the user actually wants. So we will be discussing this in greater detail later in this chapter. All right, good. I just want to make sure that I said that. Because again, people are going to say, oh, you're doing a cyclic convolution, but you gave code for a linear convolution. People will say that, and I'm like, look, I understand. The point was that the linear convolution is admittedly, precisely what you're doing in code, in that code, but the cyclic one, in the case of that animation that we just gave, is they will give you the same thing, essentially. They will give you this shape. And the thing is, the cyclic one makes more sense. If you're looking at the animation, you can look at that animation and be like, I see what's happening. Meanwhile, like doing the linear one, the convolution might not perfectly line up with a triangle. There's some things that could happen. So I'm like, let's just do the cyclic one, because it's just more intuitive in some sense. And I also want to say one final thing in here. Purple. Dash line is the output of the convolution C. Now, here's a big problem here. I'm, again, kind of... The problem is because we're convolving with square waves in here all the time, it's kind of a bit misleading, and I want to make sure okay, I need to do something that's not misleading. So it's interesting to see the blurring operation in action by convolving random distribution with a larger Gaussian filter. Yeah. I'm actually going to add one more visualization in here that I haven't written about. Is the algorithm archive like Wikipedia, wherein anybody can contribute and peer-reviewed, or is it your solo expedition? Anyone can contribute to it and it's peer-reviewed, but the peer review is really, really, really slow because I'm sorry, it's my fault. I'm just really bad at it. So here we're going to say in this, okay. This brings up a rather interesting point. What happens if we convolve a Gaussian with another Gaussian? Add animation. All right. And in here we're going to say, as one might expect, the output is is a blurrier Gaussian, which is essentially just a larger Gaussian. Man, I said Gaussian a lot. That must be my favorite word, right? The output is a blurrier Gaussian, which is essentially just a larger, or like a wider, which is essentially just wider. There we go. That way you don't say Gaussian 4 times in the same, like, 3 sentences. 2 sentences, actually. Okay. As an interesting note here, the green inside, the green area inside this visualization does not properly line up with the overlap of the 2 arrays. This is exactly what should happen. So how do I ban someone on Twitch? MATLAB, I personally hate MATLAB. It is not even a proper programming language. I genuinely hate it with a burning fiery passion. It is, I've gone on rants and tirades about how much it just sucks as a language. And there's absolutely nothing you can do to convince me otherwise. You can say, like what you say, it's the default language for almost all control theory. That doesn't mean it's a good language. That just means it's something that people are using because they have to use it, not that it's actually useful for anything. And, you can try to convince me that, you can try to convince me all you want, but I am not... I hate the language with just a burning fiery passion, and there's absolutely nothing that makes syntactic sense to me with the language that is MATLAB. So that's why I keep saying that, because it's kind of a trope that anytime people like talk about MATLAB, I get kind of pissed off about it. Like specifically last year and the year before that, during my PhD, when, I was constantly being given MATLAB code to look at, and it's just impossible to comprehend. Like the code is just like... People are so into these like goofy one-liners that I say goofy. I don't know. I think I just said goofy because of your name. That's not what I meant. But the point is, like, the more I look at MATLAB code, the angrier I get. This past year, being super far away from MATLAB code, I no longer get pissed off when I hear people talk about MATLAB because I haven't had to deal with it. And honestly, like, as much as 2020 has sucked, there is only one positive thing about the year, and that is that in that past year, I've seen almost no MATLAB code, and that is amazing. Like that is the only positive thing that happened to me in 2020, and I'm sticking to that. But if Python community can provide this tools that replace Simulink, I don't think that migration is going to happen otherwise. Python, NumPy, SciPy, Matplotlib is what you should be using. So that's the thing. I don't even know what Simulink is, right? So that's probably why, like, again, MATLAB probably has some advantage using that. I don't know what it is. So I'm assuming that it's probably some interface with some technology somehow. Right, so there's probably something useful there. In my experience, everything that I've seen people use MATLAB for is, like, you don't need MATLAB for it, right? MATLAB is the slowest part of that programming or of that code. And you could write code that's way cleaner, way easier to understand, way easier to write. It's just essentially like you can write code that's easier to understand, easier to write, easier to explain, has better almost everything if you just don't use MATLAB. But then people are used to MATLAB. And the other thing too is MATLAB writes fundamentally different than any other programming language. So what ends up happening is if you get sucked into the MATLAB sphere, it's really hard to leave because you start writing this code in this way that is very, it's just different than other languages. So you kind of get sucked in and it's hard to go from one language to the other. So then you have people who are writing code in MATLAB who genuinely think, who like, anytime I try to argue against it, they get really pissed off. And I'm like, like, it's one of those things that people get needlessly arrogant about as well, and that kind of pisses me off. But anyway, I'm not going to talk about it. I'm so sorry. I just talked about it for 10 minutes. I'm not going to talk about it anymore here on this stream. Simply put, I personally don't like MATLAB. I think that, if at all possible, you should do everything you can to stay away from that language. That's my personal take on it. Now, does that mean that people don't use MATLAB code for things? Yeah, they definitely use MATLAB code for a whole bunch of things. That's why I don't like it. I think it's the worst language to use for those things. Anyway, that is why Bajuleos is saying that, because it was a trope. I used to get really pissed off when people would start talking about MATLAB a few years ago during my PhD, just because I had to deal with it all the time, and it just genuinely pissed me off. But now I don't have to deal with it, so I don't get nearly as angry. And also, like, I'll be honest, like, I was never shouting well, a few times I was shouting, but not on stream. Like, but man, every time I thought about MATLAB code, it just pissed me off, like, really badly. Oh man, back in the good old days. Okay. As one might expect, the output is a blurrier Gaussian, which is essentially just wider. As an interesting note here, the green area inside the visualization does not properly line up with the overlap of the two arrays. This is exactly what should happen. Remember that the convolution requires a multiplication of the signal and filter, which is which is only the overlap of the two arrays when the signal is a square wave. Had to say that. Fair enough. I don't think it's the best language either, but I know it gets stuff done, especially in the area I work in. Right, that's the thing, right? Like, I think the main reason I don't like MATLAB isn't that it's a bad language. It's that it's a bad language and it's predatory, specifically for domain scientists, because they can't leave, right? So they're stuck in the language, right? Like Python, Python has so much competition. C is technically competing with Python. All these different languages compete with Python. All these different languages compete with all these other spaces. But MATLAB is the only one well, MATLAB and Mathematica are the only ones that when you use them, you're stuck using them, right? That's why. And yeah, I do blame it on the university. Like, part of the reason I hate MATLAB is that the whole reason MATLAB is big is because the whole thing, it's just like, I don't know. The whole thing is just messed up. If it gets things done, it's not bad to use. As long as you have clean code, which people don't seem to want to do ever, you might want to use it. Rust is where it's at. I know a lot of people like Rust as well. But again, like, I personally dislike it, and I think we should be encouraging everyone to switch from that language and to use something that's actually, you know, like, most people use it because they don't know. Now I'm ranting about MATLAB again. Most people use MATLAB. This is the last thing I'm going to say about MATLAB. Most people are going to use MATLAB because they don't know proper programming practices, right? So because of that, they're using MATLAB because it's the closest thing to math, and it makes sense to people who understand math. But the thing is, writing math is not always writing clean code. And so as someone who prefers to write, you know, software, you know, I'm not going to say it's the best software ever, but I try to write software that is, you know, tested and, you know, has all of the things you typically expect software to have. That's very difficult to do in MATLAB. Like, for example, tree traversal is impossible. I'm not going to ban you. I'm joking. I was joking about the ban, by the way, just for the record. That was a joke. I was totally joking. Please, 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 please know that that was a joke. I'm not gonna ban anyone for saying they like MATLAB. It's fine. A lot of my best friends like MATLAB. Like, it's fine. I just personally don't like it. I'm sorry. But besides, I wouldn't have asked, like, how do I ban someone on Twitch? I know how to ban someone on Twitch. I'm not that bad at streaming, you know? I apologize for that. I hope that was not taken, okay. Which is only lower, okay. Admittedly, let's see. Admittedly, what was I going to say? Some of my best friends are MATLAB. Some of my best friends use MATLAB is what I should have said. If I said some of my best friends are MATLAB, sorry, my bad. Admittedly, yeah. Okay, so let's just get this visualization done as well. So we're going to go here, convolution.jl, move down here, and let's just do the X and Y Gaussian. So this is going to be 1,000, out of 0, 0 there, and remove this guy, there, oops, sorry, and that should do. So here we're going to do include main. Actually, I need to change the frame output here to be 10. And let's go ahead and remove out star PNG. Open it up again, write that, go over here, run include, and now we're going to run main. This should give us a decent enough visualization of the two Gaussians moving together. Again, it's important that we do this visualization because, again, I just need to stress that the convolution is not simply an overlap. It's a multiplication at every step. Oh, okay. Just for the record. Okay. Yeah, that's fair. Got it. Sorry, I missed that. Mirage out this .png. We should see the two Gaussians come up and go back down. I will say we kind of want that convolutional area to be a bit higher. So let me do convolution.jl. Convolution periodic is the sum of y. Let me take a look at these visualizations that we have so far. Do I need a scale factor? I need to think about this really quick. So here's our convolutional output, which before when we did this, we said it was a sum of y. Yeah, okay, that makes sense for that one. And this one up here, also the sum of y. Okay, so both of those make sense. Now for the random distribution, did that one actually make sense? So let me just do MPV, 1D rand Gaussian.mp4. I think that makes sense as well. Probably should have normalized things, but it's okay. I think having it not normalized is totally fine. Yeah, and we're just because we wrote in the code that you should normalize it as well. So, I think that's okay. Cool. Okay, so we're gonna keep going. So we have the two convolutions of the two Gaussians. So we're gonna do. I'm on the wrong desktop. So here we want to do. It's gonna be sum of y times y. Should work. Write this. Go over here. Include. Now we're gonna run main again. And now we're going on to the triangle wave visualization, and we're so close. We're so close to finishing this up. Quit here, Mirage. So we should see the convolution go up go back down. Perfect. That's what I wanted to see. Okay, let's go over here, run one of the FFmpeg, which should be this one, and we're going to change it to out25.mp4. Ah, no, out26.mp4. There we go. And then over here, we're going to say, here, so let's go with CP over, and we're going to say, double Gaussian .mp4. Okay, now we have to put it in here. So I think it was 6 again, yank, 6 yank, and we're gonna paste it down here. Well, that is shown below. All right, and this is gonna be called double Gaussian.mp4. All right, DD there, and I believe we have a few more visualizations to do. We still have to do the triangle with the square wave. And we have to add the image of the triangle wave. So we're getting close. Or the sawtooth function. Okay, I'm going to write that. That's going to rebuild it, but I think some of the visualizations just won't work yet because, yeah, we're going to have to rebuild the entire algorithm archive. So let's do that. Control-C, rebuild it. Oh, man, we're so close. There are way too many animations in this chapter, though. Which is, I don't know. I don't know if that's a good thing or a bad thing. Go ahead and refresh over here. Oh, it's still building. Now we can refresh. Refresh. Perfect. So we have this animation there. Animation. So here's this animation. We have that one. But this one should be the double Gaussian. I see what I did wrong. So I copied the wrong one. It should be out 26. Okay, well, that'll be the right visualization next. So now we have to fix the sawtooth one. So finally, let us extend this concept to one final example of a square wave convolved with a triangle sawtooth function that looks like this. Maybe you missed the earlier question. Is the algorithm archive like Wikipedia where anybody can contribute? I did answer that, but maybe you missed the answer. The answer is yes, it is definitely peer-reviewed, but we are very slow with the peer review process. Again, if you want to help out, just feel free to go to github.com. And algorithm archive here. And the easiest way to help out right now is just by going through pull requests. If there is a language that you know, like let's say you know Elvish, although honestly, I don't know who actually knows Elvish, but let's say you know Elvish or you know Go or you know Monte Carlo or you know Racket. If you know any of these languages, just going there and just reviewing and just saying, hey, this code makes sense to me. That's all I need. I can run the code. I can make sure that it's outputting the right results, all that kind of stuff. We do actually accept MATLAB, but I don't think we have any open MATLAB PRs. Do we? We do not. But this is what we have so far. I'm going to go ahead and put this here. That's the easiest way to help out. Just look at the code and be like, hey, this code makes sense. You don't have to know the algorithm. Just look at the code, and if the code looks good, that's all I care about, because I can check the algorithm. I just need to make sure the code is like, part of the reason people are using the algorithm archive is to also get, decent coding implementations in their languages, to some extent, right? It is a learning resource, but to some extent, you kind of want to see, hey, this is how I do a convolution in a rather naive way, right? Technically, there's not any chapter that James here did not write. Yeah, I'm just really slow. I'm sorry. I'm bad with reviews. Like, I really suck with doing chapter reviews. The difference between chapter reviews and code reviews is that code reviews, in general, there's like a guideline. Hey, Trash Talk, how are you? I think you said that earlier, and I just missed saying hello. I'm sorry. But yeah, the problem with code reviews, or the thing that's easy about code reviews, is you can look at like PEP 8 guidelines or something like that. There are certain guidelines that you can follow, and you can say this is within the guideline, this is without, outside the guideline, all this kind of stuff. You can't do that with chapter reviews. And a lot of times people will write a chapter and it just won't be sufficient, or it will have like bad English in there, and I don't know, just uploaded another ISUET article. Nice. Yeah, actually those actually turned out really well. I'm a big fan of those. Okay, so the next thing I'm going to do is I move the double Gaussian over, so now we have to do the triangle and the square filter. So let's do that. Again, we're just churning through the animations today. I wonder how many people actually read them. I don't know if too many people read them, honestly. Like, I wish more people did, but it is what it is. I'm guessing at least 3. I mean, I read them. let's see. Trash Talk, you feel free to talk about it, but it's a series that Trash Talk has been writing. And it's on the writing repository in the Algorithm Archivists. Okay. So I'm going to, we don't want this guy, so we want to do the square wave, which was this one, with the sawtooth function, which was, I don't think I have the sawtooth one. So it will be, y is going to be equal to, right, so it's kind of, if you go to the writing channel on Discord, here, I think I can just do this for Discord. Feel free to go there. We have a writing channel there where we talk about different writings that we've done. It's something that I enjoy doing, and I do somewhat regularly on stream where we just do like a writing Wednesday or something like that. And yeah, we see how it goes. Some people like them, some people don't, but that's okay. You know, not every stream has to be like, you know, if you like technical content, I do a lot of technical content. If you like non-technical content, I'm kind of sort of trying to do some of that recently. You know, I did a few gaming streams. I kind of want to do some more gaming today. And obviously we have the writing streams and stuff like that. Okay, so we're gonna do y is gonna be equal to, and we're just gonna have the triangle wave going up. So it'll be a float of I divided by, and I'm just gonna say it's gonna go up to. This is the visualization we have so far, and it goes up, and then it goes back down. Okay, so we want it to go. Oh, what is going on there? Float of I divided by 400 for I is equal to 1 to 400. And then I'm just going to add, so I'm going to say y is going to be equal to vcat of zeros of, what is this? It's going to be zeros of 400, 400. Wait, that doesn't make any sense. 400 to 600, that's 200. Okay, I got it. And this is going to be 400, y, zeros, 400. All right, let's see what that visualization looks like. So we're going to do include here, run main, take a look at the output. So do you pitch yourself differently from CLRS or TAOCP? Or is this more like repository of codes for all the algorithms? So CLRS is a very common book on algorithms. TAOCP, the art of computer processing, which is, okay, so both of those are actually on a different vein. We are most like, if anything, numerical recipes. So in some sense, you can think of us as a mixture between numerical recipes and maybe Rosetta code or something like that. So that's kind of the idea. It's not exactly that, but it's something like that. So in some sense, what we're trying to do is provide, you know, intuitive animations for, you know, various topics, whatever those topics happen to be, along with, you know, concrete code examples in whatever language you want. That is basically like a better, like an upgraded version of numerical recipes. That's kind of what we're shooting for. This is different than CLRS or TAOCP because both of those books are more from a theoretical perspective. This is more from an applied perspective. So that's kind of what I would say the difference is. The newsletters from Official University, yeah, they're actually quite good. I enjoyed reading the ones I have read. Let's go here, 1 second, and let's just take a look at Mirage. And we should see, oh, that triangle is starting in the wrong spot. Right, that's because we have to do this guy. And paste it down here. Do that, and now it's gonna be the sum of y, not y squared. Go over here, run include main, try it one more time. And then we should have a decent enough visualization for this one. All right, we're gonna run Mirage, and we have the triangle starting on this side. It should go up, and then it goes back down. Wonderful. That looks really nice. Okay, so let's get that visualization ready to go. Quit here. And now we're gonna do 26.mp4. Oh my, are you kidding me? 27.mp4. I called it 20y. Okay, move output to y to output to 7.mp4. All right, then we have in the appropriate directory. The next thing I need to do is output that sawtooth function. So let's see, do I have that? I should have the PLT is equal to that. Wonderful. Okay, so now I'm going to say y. What did I do? Okay, G here. And we're just going to grab this guy in here and paste it in here. And now I'm just going to do... Oh, no, this is correct. That's what I want to see. So now we should do PLT is going to be equal to y, and we're going to call it the sawtooth. Read the contradiction article. Looks cool. It's really cool. So we're going to do PLT here. And now we're just going to do save fig sawtooth .png. Okay, so if we do mirage sawtooth.png. Okay. We want to just do this bit. Oh, sorry. That. Paste in here. And now we want to do PLT. And now savefig. Now if we take a look at that. Okay, there's a sawtooth filter. Perfect. So we're going to go over here and we're going to paste that in as well. Here, Wendy. That's not what I meant to do. Okay. Actually, I do need to go back over here. So we're going to cp27.mp4, and we're going to call it sawtooth. 1D sawtooth, I guess. Yeah, that's what I want. Okay. Now let's go over here and let's just do yank 6 yank. Paste that down here to the animation bit. Oh, that's a triangle animation. Oh, right. So this is going to be here. Paste, and we're going to change that to the 1D sawtooth animation. Perfect. So 1D sawtooth animation. 1D sawtooth? What did I call it? 1D sawtooth. I think that's what I called it. Yeah. Okay. The other thing I need to do is copy the sawtooth.png over here. Okay, and let's open that up again, and we should have, here's the images. Perfect. And we're gonna make this of size 50% or something like that. Where are we? 1 second. This. And now we should do image. Should be here. Sorry, open this up. Paste there. DDDD, and it's going to be sawtooth.png. Okay. DD here, we're going to make it a size. Let's make it a size 60. 60. Okay, so that should be good, and that means that we're now at the dealing with boundaries section. So I'm going to rebuild the algorithm archive really quick. Control C, npm run serve, and this should be fine. I don't want to clutter the chat with unrelated talk, but I'm curious. Do you think the sport would actually work? Wait, what sport are we talking about? I missed something. I read the... Oh, the new one. That must be a new sport. Maybe I'll talk on Discord when not watching the stream, if you remind me about it. Yeah, I think we should be using the Discord a bit more for the writing streams and the writing talks and stuff like that. Okay. So here we have that visualization. We go down. These visualizations, again, that one works. The sawtooth should be centered for some reason. It's not. And then this visualization here. Good. Okay. So now we're at dealing with boundaries, and we're so close to finishing, guys. Like we are, like we can get this done in the next 30 minutes. I'm almost positive we can. Okay. So this was not centered, and I don't know why exactly. So let me just quit here. Go back to tree traversal. Traversal, and then tree traversal.md, and go to center, and let's just grab this guy. Okay, quit here, open up 1D, img, paste this here. Let's try that again. All right, open that, paste it here, perfect. And then it's going to be the following. resources, whatever, sawtooth.png. Okay, and it says width 25, but actually I want to do width 60. And that should be centered, I believe. Yeah, that's centered. We have the sawtooth function. Perfect. These animations should all play just fine. Nice. That one does. And this one does as well. And this one does as well. Okay, good. So finally, let's extend the concept to one final example. All right, well, I'm going to remove finally because I'm being redundant. Let us extend this concept to one final example of a square wave. Convolved with a triangular sawtooth function that looks like this. This is the first non-symmetric filter of this chapter, and its convolution would look like this. Non-symmetric filters are useful for testing convolutions to ensure the output is correct, so it might be worthwhile to linger on this animation for a bit longer. Notice how the convolution has a steep positive slope when the reversed... My triangle is backwards. Notice how the convolution has a gentle... I'm just going to rewrite this. Gentle positive slope when the reverse sawtooth function interacts with the square. This makes sense as the smallest part of the triangle interacts first. Part of the triangle interacts first. Has a gentle positive slope. Well, we'll say has an accelerating slope. Has an accelerating positive slope when the reversed sawtooth function interacts with the square. This makes sense as the smallest part of the triangle interacts first. Similarly, there is a large negative slope when the sawtooth... there's a large... there is a negatively accelerating slope when the sawtooth function leaves the square. Now I am going to modify all these saw dash tooths to be sawtooth. Or maybe, what is a sawtooth function? Sawtooth. Yeah, okay, there is no dash. Saw dash tooth. Here. Next. There. Next. Okay, so we removed all the sawtooth. Great. Okay, so now we're at dealing with boundaries, and I think we have everything up to this point basically done for the 1D chapter. Okay, we're so close. I'm really happy to see that this chapter is basically done. Contradictions is a game invented by Brian David Gilbert. Oh, interesting. Maybe I'll talk about it. Okay, so this is good so far. So dealing with boundaries. In all of these cases, the output array... in all these cases, the output array... Okay. In all of these cases, the visualizations, animations have been periodic. Wait, let me see. Oh, Brian. Fair enough. Let's see. Periodic should be down here. Who doesn't like that fabulous man? I don't know who that is. I'm so sorry. I probably should. Have been periodic. 1 second. With this condition, the filter will wrap itself around to the other end of the signal when it hits its boundary. So let's see, since we, this is gonna be a bit complicated to write. In all of the animations, we have shown the filter leaving, filter reappearing on the left edge edge of the screen. The filter constantly reappearing. Constantly. Okay, oftentimes. That said, this is not always the best thing to do at the boundaries. Oftentimes, I think the main thing he's known for is overanalyzing video games and video game universities. Interesting. I don't know him from much else. Oh, wait a minute. Oh, maybe I do know this guy. Is this the guy that... I do know this guy. He has he's an amazing YouTube channel. Although I misspelled it. Yeah, I didn't know he did video game stuff. But his YouTube channel is amazing. Like, for example, this video. I very much enjoyed this video. Yeah, like, I didn't know he did gaming stuff. But he's got a lot of really good videos on his channel. So I do know who you're talking about. Sorry about that. In all the animations above, we have shown the filter constantly reappearing at the left edge of the screen. That said, this is not always the best thing to do at the boundaries. Oftentimes, when we're using a filter on an array, in fact, these boundary conditions are somewhat non-trivial to code. So the previous code example, they will be covered at the end of this section with periodic boundaries. I note that there are different methods to deal with the edges in this case, so it must be, let's see. I think this is fine. In all the animations, we have shown the filter constantly reappearing at the left edge of the screen. That said, this is not always the best thing to do at the boundaries. In fact, these boundary conditions are somewhat non-trivial to code, so they'll be covered at the end of this section. So we have simple boundaries and then periodic boundaries. In the code example, in this section, let's see, are somewhat non-trivial to code. In fact, these boundary conditions are somewhat non-trivial to code. Which OS to use? Yeah, thanks for that. Use DuckDuckGo. I hop between DuckDuckGo and Google. Usually I can't find the right results with Google, so I try with DuckDuckGo and then I fail and then I open up in Google. That's what ends up happening. A lot of people say they get really good results with DuckDuckGo. I don't, usually, so I have to kind of work around that. In fact, these boundaries are somewhat non-trivial to code, so we will start with relatively simple boundary conditions that were actually introduced in the previous code example. Okay. Since we already know that a naive convolution will result in an array, the length of both signals... okay. Simple boundaries. So here we're going to say, in general, if a user wants to see a full convolution between two signals, the output size must be the size of the two signals put together. Otherwise, let's see, otherwise, we cannot traverse through or iterate through the entire convolutional output. Okay, so in general, if a user wants to see a full convolution between two signals, the output size must be the size of the two signals put together. Otherwise, we cannot iterate through the entire convolution domain. That said, most of the time, there are many applications where the user actually needs to specify the output domain to be another length. Like, for example, such as the size of one of the input signals. Okay. So let's see. So what I had written before is, since we already know that a naive convolution will result in an array the length of both signals put together, we might now be tasked at providing a simple boundary for the case where the output convolution must be a defined size, usually the size of the input signal. Okay. In this case, the simplest boundary would be to assume that whenever the filter hits the edge of the image, it simply disappears. Another way to think about this is that the signal only exists for the domain. Only exists for the domain where the domain we specify it over, and is all zeros outside of this domain. Therefore, the filter does not sum any signal from elements beyond its scope. As an example, let's take a random distribution convolved with a Gaussian filter. Okay, so here we're going to do the simple boundary conditions that we had before. So as an example, let's take the random distribution convolved with a Gaussian filter. Okay, so I'm going to now do the random distribution convolved with a Gaussian filter. Because that's what I said I would do. And I am nothing if not a man of my word. I say that, but I try to keep my word, but sometimes I fail. Okay, so if we do this and we change this to the, do we want to do linear or do we want to do simple? What is the difference? Okay. For example, here is the Gaussian distribution convolved. Here is random noise, again convolved with a Gaussian function, but with non-periodic boundaries. So I'll add animation. This shows the full, let's see. This shows the full convolution of the two signals. So in some sense, it is the most correct convolution, right? Because it shows everything. But okay, in general, if a user wants to see a full convolution between two signals, the output size must be the size of the two signals put together. Otherwise, we cannot iterate through the entire convolutional domain. Let's see. There are many applications where the user actually needs to specify the output domain. Okay. In this case, the simplest boundary would be to assume. Okay, so let's take the random distribution, the same random distribution case. Example as before. Take the same random distribution, convolve, well, the same example. Example as before. Okay, so now we have the animation there. Here we see that the convolution needs to ramp up and ramp down. Yeah, I think we actually want to put this. Like in the case where we did not have bounds. However, the convolution output no longer extends past the boundary of the original signal. Okay. We clearly see a ramp up and ramp down phase at the start and end of the animation, which is again what you expect. We clearly see this shows the full convolution of the two signals, where we clearly see. Okay, and down here we're gonna say similar to before. Let's see. So we say similar to before. The convolution needs to ramp up and ramp down. Similar to the case without bounds. I'm sorry, I'm doing like editing here. Yeah. I try to keep the editing off the stream. I didn't realize I was so far from finishing the chapter on the simple boundary thing. So here, so this shows a full convolution. So in general, this shows a full unbounded convolution. This shows the full unbounded convolution of the two signals where we clearly see the following. In this case, the simplest boundary condition. Yep, okay. This means that we're actually, okay, so more than that, the convolution does not go all the way to 0. This means that we're actually ignoring a rather important part of the convolution. This is 100% true. However, if the signal is large and the filter is small, as is the case with most of image processing, we do not really need to care that much about the bits of the convolution we missed. For this reason, simple bounds are used frequently when performing convolutions on an image. In code, it might look like this. In code, it is exactly the same as before. As what we showed previously. And I think I'm just going to re-add the code in here. So let's see. I think we had it up here for the methods. Man, this is a long chapter. So we're going to do yank for yank. Go down here. Oh man, okay, I might stream for a bit longer just to get this done, because we're so close to being done. So let's just paste it in here. DD. Oh. D4D. Okay, paste in here. Here are the main differences between the bounded and unbounded. The bounded and unbounded versions. Let's see. Here in code, both of these, both the bounded and unbounded. In the previous code that we wrote, we were able to perform both a bounded and unbounded convolution. Here it is again for clarity. The main difference between the bounded and unbounded versions is that the output array size is changed. Is smaller in the bounded case. The rest of the code works precisely as it did in the for example, the unbounded function would be called with a size with the output array size specified to be the size of both signals put together. On the other hand, the bounded array, the bounded call would set the output array size to simply be the length of signal 1 of the signal. All right, now I have to add the code, so let's do that. Add code. I'm really hoping the periodic one doesn't have as many changes need to be done. That is it for simple boundary conditions. Now let's talk a bit more in detail about the animations, the boundaries, the animations. All right, sounds good to me. So let's add that code, and then we can go from there. So there we go. I was going to vi code Julia and then 1D convolution.jl, move down here. And I think we're just going to do full linear output, and so let's do set number, and it's going to be a line 69, nice, and 72. Okay, so let's do yank for yank, and we're going to paste it here, delete that, and paste it here. Okay, that didn't work. This is going to be on line 69, and the other one's going to be on line 72. All right, change that to a 7.2. Okay, and then we can add in the animations. And yeah, so that section looks like it's pretty much done. There might be some issues. For example, the unbounded function would be called, so the unbounded function for an unbounded convolution function for let's just do that. For an unbounded convolution, the function would be called with the output array size specified to be the size of both signals put together. Let's just write that. And in principle, that should rebuild it. And we can just check the code. So we have the code again here for clarity. So, nah. I wanted one line, but it put the entire code there. So maybe I need to do import. How about we do 68 to 69? 68 to 69. And down here, we're going to do 72 to 73. Okay, rebuild that, see what it looks like. So we're going to go down. We have the function again. Then we have the full convolution. I think it was 71 to 72. Try that again. And then we can put the animations in there. And we're getting close. Like we're very close to being done. Simple boundaries, full convolution, nice. So now we just have to put the animations in there, which should be here and there. And then we have the simple boundaries done. And now we can move on to the periodic bounds after that. So let's go ahead and get those two animations done. So we're gonna do a simple convolution there. And yeah, I know chat got pretty quiet, but that's okay. Like that happens sometimes. Like, you know, you'll see streams with like hundreds of viewers and chat isn't super, super like active sometimes. On streams like this, there isn't really much to talk about, right? Yeah, exactly what Trash Talk just said. I'm just kind of doing the work. We're just waiting for the bot to say he's a cinnamon roll. Yeah, sorry about that. Okay, so let's add those animations in. So we have the simple animation here, and then we have the convolution linear. So I think if we do include convolution, and this should be, yeah, it should be the same. Then we're gonna run main. Oh, actually, quit here, write and quit here, remove out star PNG. I'm gonna include it one more time, and then run main. Let's take a look at that visualization. Yeah. This one should go up to size 100, I believe. Yeah. So now I look at that, Mirage, Sawtooth. Where are we? Here? Nope. There. Okay. So we should, ooh, that's pretty, I just convolved a random distribution with a random distribution. That was not what I was anticipating. All right, let's try that again. So that's because it should be X and Y. Include main. Okay, give it a second. Try that. So here we have the, what is going on? Why am I so dumb? I'm doing something stupid and I don't know exactly what I'm doing that's stupid. So let me try this again. Why in this case? Oh, I see what happened. Okay, let's just comment this out. Okay, now Y should be the Gaussian. And right, so we don't want to do X star X anymore. We want to do, well, let's just see what happens. Include main. I modified the convolution curve. That looks nice. Yeah, I think it's almost done. Like I spent all week on this, and like I know it doesn't seem like I spent all week on this, but like it's taken a lot longer than I anticipated. let's remove this part. Yeah, I'm just messing around here. Include main. We've got a few more of these convolution visualizations to do. So Mirage. Okay. Yeah, so here we see that the... Yeah, okay, so it doesn't actually have a ramp down. Ah. So let's actually go over here and let's fix that in here. So, similar to the case without boundary conditions, this convolution needs to ramp up, but not ramp down. This is because the convolution output no longer extends past the bounds of the original signal. There we go. Random question: Did you ever in your grad school find a particular course very hard, or maybe did not get the gist of it, and would like to revisit it and now give it another shot? In some sense, yeah. What is your background and what kind of stuff do you usually stream? Well, sorry, the info is below. Yeah, it should be down there, but if not, I usually do stuff that's like related to algorithms and stuff like that. Goofy Lagrangian, yeah, there is a particular course like that. It would be probably adaptive systems for me. There was a lot, like, it's basically machine learning, but I just didn't learn it as well as I could have. So I wish I would have gone back and I wish I would have like learned more in that class, is what I'm trying to say. Okay, so what I'm going to do next is I'm actually going to make it so, I'm going to try to make it so this guy is only going to 50 and this goes to 25. Okay, so let's do this, include, and try that, main, and see what we got here. But yeah, I generally do algorithms and stuff like that. That's my thing. So, we're super quiet today, though. To be accepted at MIT, is it necessary to have 4.0 GPA? No idea. I was never accepted into MIT. So we should be able to just go up. Yeah, that's pretty okay. Yeah, okay, I think that's fine. That'll be fine for that visualization. I think that's fine. Okay, let's go here, quit, run the last FFmpeg for that, and we're gonna call it out28.mp4. Over here, copy that over, quit, CP, and we're gonna call it out28.mp4, and we're gonna call it 1D rand Gaussian simple.mp4. Okay, so now we're gonna do the same thing, but with the full visualization. In fact, maybe I want to do something else here. Let me do changes to sum of y, and then we're gonna do include run main, and we're gonna take a look at that. I am a senior math major who wants to do PhD in stats, but needs to work first for money. Wish I could just do research. Yeah, actually, I did a lot of, by the way, it's Suyato, thank you so much for following. I really appreciate that. I personally, wait, are you telling me to chill? Sorry about that. I might have, I got kind of tired in the past 10 minutes somehow. I don't exactly know what happened, but like I just passed the 2-hour stream mark and now I'm like super tired for some reason. So I might not be answering these questions to the best of my ability, and I do definitely apologize for that. But what I will say is that for most of the PhD programs that I was applying to, I was paid to go. So I don't really know how it works when you don't get a stipend to work for the university. Usually you work for the university as a teaching assistant or something like that. So I don't really know. But yeah, that feeling like I wish I could just do research, I think that's always going to be like just the feeling that you'll have when it comes to just being an academic, you know? It's not scholarships, it's a stipend. You're working for the university. It's slightly different. There we go. I'm going to fight Darkling, and by fight I mean cheese him out with Din's fire. Yeah, sounds good. To Pudding, where you were waiting. Like, you were just waiting. Because you said it all the way up here, like 20 minutes ago. Or 10 minutes ago, or whatever. I would if I didn't have people dependent on me. Oh, that's fair as well, I suppose. Okay, let's take a look at these visualizations. Mirage, so we should see it go up. And then it stops. I think that's better. Yeah, let's do that as the visualization. Okay, so we're going to quit here. And we're going to do that. Yes. Okay, now we have to do one more. So we're going to copy that over here. Oop. Copy that over here. And I'm going to put it in here as well. So we should have an animation. Oh man, this is turning out. So let's do yank 6 yank. And for the simple boundaries, we're just going to put it down here. I don't remember what I called it, but that's okay. I think I called it 1D rand Gaussian simple. Rand Gaussian simple .mp4. Now we have to do the last one, which is going to be with the just convolution linear. Comment that out and that out there. And then let's see what we got. So we're going to run include, and actually we're going to change this to sum of y like we did before. So here we're going to do include. Now we're going to run main. Okay, I plan to work as a data scientist and then doing a PhD if I'm still interested. I'd be satisfied working as a researcher at a company because all I care about is learning more. Yeah, I totally understand. What are you working on right now as an academic? Honestly, the algorithm archive, I'm not really doing much academically. I actually just finished my job at MIT. I'm on my way out. It's not, I got really burnt out at MIT. So that's kind of what happened. Yeah, there's your full convolution. Nice. Okay. So let's go here, quit, run this, and it's going to be out 29. Oh, we have one more visualization to do. I'm so happy we're almost done. How many PhD programs did you apply to? Me personally, I applied to 5 different PhD programs. I applied to Auburn University, which was a university I had already gone to as an undergraduate. I applied to OIST, the Okinawa Institute of Science and Technology. I had another application to the University of Austin in Texas. And then I had another to the University of Pennsylvania. Wait, 1, 2, 3, 4. Is that 4? I think maybe it was only 4. I thought there was a 5th one, but I don't know what the 5th one is, so I don't know. But I will say at that point, that's fair. Has a PhD, can't count. To be fair, name a number of PhDs who can actually count correctly. It's going to be smaller than the ones, like, I would guess that most people who have a PhD are probably beyond the counting stage in their life. 1D rand Gaussian full .mp4. Okay. And now we're going to add that here. So yank 6 yank. There was something I was going to say and I missed it. 1 second. Let me catch up on chat once I put this in here. Change this to a full .mp4. Oh, we're so close. We're so close. Okay. Let me just rebuild the algorithm archive. And while that's rebuilding, I just closed the browser. I did not mean to close the browser. That's okay. Yeah, so I was super lucky with graduate school. When I applied as an undergraduate, why did I open up LibreOffice? Of all things to open up. When I was applying for my graduate studies, I had already done research for like 5 years as an undergraduate. Well, no, not 5 years. That was too much. I had already done research for 3 years as an undergraduate. So that was really what I was relying on. I wasn't really relying on my scholarship. Like I did not do super well in classes, but my research background was quite good at the time. And so that's what really helped me for most of my applications. I knew what I wanted to do with research, and that's what I did. So here's that convolution. I'm going to have to come back through and kind of like read this again tomorrow. But again, it's pretty good. So that's the full convolution. So here's the one with the boundaries cut off, and it has a ramp up, but no ramp down. Perfect. Okay. And these guys should probably stop. Yeah, so these guys should stop instead of cycling through. So we want to not loop that. And we're not going to loop this guy either. And then that should rebuild. And we should be able to just play those and they should stop at the last frame. Yep, so this should stop at the last frame. Let's see it. Yep, looks good. And perfect, stops at the last frame. Whenever my friends play poker and I'm counting chips, they make fun of me because I'm slow and I'm supposed to be good at math. Yeah, I mean, good at math is way different than being good at, like, arithmetic. The PH test, thank you so much for following, really appreciate it. I've looked into learning the tables from 1 up to 100 is doable. Wait, what tables are we talking about? What were you doing your undergrad research in? Did you have publications? I did not actually have publications. I kind of wish I did. I did my undergrad research in a group of different things. So I started out my research doing psychological research, looking at pain tolerance in suicidal patients. From there, I then moved on to talking a little bit, like I started learning more about like how fMRIs worked. And then I did research on various areas of plasma physics. So I did computational plasma physics, where I studied molecular dynamic simulations. And then after that, I did, what did I do after that? I also did like supernova remnant plasma physics and stuff like that. So it was largely a bunch of simulations. I worked for an experimentalist, a theorist, and a computationalist. So I had some really good background by that point. Again, I didn't get too many publications. I still don't have too many publications, but I did a lot. And so by the time I finished my PhD, by the time I finished my undergraduate, I had a pretty good application. So, but no publications. I'm generating, plotting, and writing 4096 plots to disk is slow. Yeah. I need to learn more DSV. Yeah, I'm glad you're here. Should probably try to parallelize that. If anyone's curious what I found in Water Temple, it's a bounty, serious song of storms, and hover boots. Interesting. 27 times 37, 11 times 92. Ah, okay. So I don't even know up to 10. So if you can learn up to 100 from multiplication tables, like, good on you. Maybe I'll apply to see if I can get into a really good program. I did research in astronomy, finance, stats. Yeah. So the one place that I applied to that I very much enjoyed and I loved going there is the Okinawa Institute of Science and Technology, or OIST. Yes, this is your typical OIST plug for the stream. I haven't done this in a while. .oist.jp. So I went here as a graduate student. It's like a really cool interdisciplinary program. I would definitely recommend checking it out. It does all these different types of science. I really enjoyed it. But anyway, that's my OIST plug. Noob question. Charter of View, thank you so much for following. Really appreciate it. Cross it off on your bingo cards. What's your noob question, the pudding? Okay, so we have that down. That's it for simple boundary conditions. Now let's talk a bit more in detail about the boundaries. We're so close. How important is the place you're going to do your PhD at culturally? That's that's a tough question to answer. Because it really depends on what you're looking for. Right, there's two ways to answer that. The PhD is where you're going to be spending 5 years of your life, maybe more, maybe up to 7. And I would argue that if you are going to be spending 5 to 7 years of your life at a particular university, you should like the people there. You should like the culture. And so in some sense, you need to find for yourself what you actually enjoy. Do you enjoy cities? If you enjoy cities, go to a university in a city. Do you enjoy, living in the countryside? Well, then go to the countryside. That matters. It really does. A lot of people say it doesn't, but it really does matter. The other thing that really matters is the research culture, right? Which is, how do I put this? If you're going to do research, are the people who are doing research there going to move your career in the direction you want to move in? That's the important bit. That's what you have to answer, right? And so going into my PhD, I had a bunch of different directions I wanted to go in, and OIST, being an interdisciplinary university, allowed me to explore what I wanted to do. And so for that reason, I really did enjoy my process of being there. What research groups is that university known for? There's a couple of good groups. I mean, it's got quite a few in quantum physics, quite a few in, machine learning. Just here, let me go there. Missions.oist.jp. Let me just go there one more time. It actually has here the research. If you do faculty and research, it kind of lists all the different research groups that there are. And so if you're kind of interested in more, we'll say, they don't I'm glad they removed it. But engineering and applied sciences, for example, they used to have one for computational sciences, and mathematical and computational sciences, for example. Yeah, so you can just kind of look here and see what people are interested in. And so I would say that's what I would do if you were looking. So if you're looking for a place, what I would always do is I would first look at the research and I'd be like, hey, does this person have, does this university have interesting research? That's number one. Number two is this a place that I actually want to go to, right? And if both of those are yes, apply to the place. If either one of those are no, don't apply to the place. That's what it is. It's a simple and operation between those two statements. That's what I would normally say. Let me just put this in chat, just to say that I did. And let me see, what do we have here? I feel like I could easily land a PhD spot on places I wouldn't like to live at. So it's important after all. It definitely is important. That means I wasn't wrong when I rejected specific places I wouldn't even visit for fun, right? I mean, you can look at it as 5 to 7 years of your life that you're going to hate, but why are you going to spend 5 to 7 years of your life in a place that you're going to hate? Like, why? Like, you're just, you know, it would be cool as a statistician because I could dip my hand in multiple domains. Right. I don't really know if there's too much statistics, so definitely look at this and see if there are people there that are interesting. I'm happy as long as I have my PC. I thought that as well, but when I went to MIT, I realized that wasn't true. Like when I went to OIST, I thought that. I was like, as long as I have my PC, it's okay. But I kind of realized that there was a lot of stuff that OIST did right that I really enjoyed. And when I came to MIT, I was like, well, I have my computer, I'm going to be fine. But honestly, I wasn't. It could have been because of COVID. It could have been because of a number of different things. But quite frankly, I had that mindset and I was proven wrong. You have the mindset and you might be proven right. I don't know. Just for me in particular, I realized that living in a place that I enjoy does actually matter a lot to me. Hey, non-dairy neutrino, how are you? Okay, so we're going to keep going with periodic boundary conditions. So another relatively simple boundary condition is the periodic boundary condition. Okay, so let's see. So we're down here. So another relatively simple boundary condition is the periodic boundary condition. With this condition, the filter will wrap itself around to the other end of the signal whenever it hits the boundary. In this way, the signal is periodic, with an identical copy of itself acting as left and right neighbors. Those neighbors then have other neighbors, and those then have neighbors creating have more neighbors. Other neighbors, and then have more neighbors. Creating a sea of signals extending to infinity and beyond in both directions. For us, this means that when the filter leaves one edge of the domain, it simply appears on the other opposite edge. This particular convolution is known as a cyclic convolution. It is also the most common output of convolutions that work via the convolutional theorem, which will be discussed in another section. Here again is the same example. Here again is the same visualization we showed above, as a reminder. Here is the same cyclic visualization we showed above, with a random distribution and a Gaussian and signal. For clarity, all right, there we go. We already had the visualization done. I don't remember what I called it. 1D rand Gaussian. Okay, .mp4. Okay, in code, this typically amounts to using some form of modulus operation as shown here. As a final note before continuing, dealing with boundaries is tricky business and can dramatically change the behavior of the output convolution. For this reason, it's important to think about what types of boundaries will work best for what you, the programmer, actually needs. The selection of correct boundary conditions. The selection of boundary conditions will be a common trope for a large portion of computer graphics and physics algorithms, where researchers often need to present and simulate data on an array of some sort. Okay, let's go from here. Let me see. I missed a lot of chat, so let me go ahead and catch up. It doesn't have to be, let's see, what did you not enjoy about MIT if you're willing to talk about that? Yeah, I mean, I'm very open about it. The MIT job was great, but it had the same issues that I had with the OIST job, and that it wasn't exactly where I wanted to go. So I wanted to do a lot of computation, algorithms, stuff like that, hence the algorithm archive. But when I actually did the work at MIT, I was doing more physics simulations, and I personally am not a big fan of physics simulations. They're fine, but I don't feel joy when I'm doing physics simulations, right? And so I was hoping to do something more algorithmic, maybe like distributed transposes, just weird operations that you can like make better. And so that didn't happen. And so because of that, the work life wasn't particularly good. And also it was really stressful because we had to get, I was basically a software engineer, right? And so saying all I needed was my computer, well, all I had was my computer, and I had to constantly write code that I didn't really care too much to write. And so that was why the MIT job wasn't exactly a right fit for me, because the job wasn't where I wanted to be, and it wasn't leading me where I wanted to go, and so research-wise, it wasn't a good fit. Also, I do not like the city of Boston. OIST was amazing. You're living on a subtropical island off the coast of Japan. It's genuinely amazing. Boston? I lived in a rat and roach-infested apartment for a few months. Then I had to move back in with my parents when COVID hit. Like, this past year really just hit me hard, and it made me realize that I need to do something different. And so this year, I'm basically taking time to work on my own content, to help to do this other job that I haven't talked about yet. And I am really hoping that that helps me at least set my career back onto a more algorithmic computer science direction. So that's the reason I didn't like MIT. It was the living conditions I didn't like, the research I didn't like. The whole thing was just hard because, and not only that, but I was in a distance relationship for the past year and a half almost, and with COVID, me and my girlfriend weren't even able to see each other, and that sucks. And I'm not gonna say like I'm not gonna like mope about that, but it is something to mope about, It is enough that I felt like I should, I don't know. It was enough that altogether last year was one of the most stressful years I've had in my life, I think. Maybe there was a more stressful one, but last year was really tough. The PhD was tough. Last year was way tougher, like just way tougher. What did you not? A lot of people think it is. May I ask a technical question about astronomy? You can try. I don't know if I can answer. I had a really similar experience when I applied to university. I was thinking, give me the best degree possible. But now that I'm here, I realize I was immensely lucky that my university has good societies as well as good degree. Right. Nice YouTube channel. Thanks, man. Or woman or child. I'm sorry. I did not mean to assume a gender. Does there exist such a greater purity of being than experiencing a good grilled cheese? Man, now I want grilled cheese. I'm interviewing with a company in Boston. Yeah, I mean, you can probably find a better place to live than I did. I didn't like it at the time. What do you think about the interpretation of redshift? Is it more accurate or appropriate if we use Compton scattering and plasma physics or Coulomb? I'm gonna be honest, I don't have an answer for you. I always thought redshift was more of a, now hear me out here, don't hate me for this. I always thought this was more of a like speed of light type of thing, like a what is it called, like a relativistic effect. I'm probably wrong about that, and I'm so sorry that I don't have an answer for you. It's been a long time since I did plasma physics, and again, it was only at an undergraduate level, and so I know I was just boasting about my undergraduate research, but again, I unfortunately can't answer that question. I'm so sorry. Okay, so now I'm in an interesting, well, okay, let's just go here. Okay, so we're gonna do, I need to think about this really quick. I just realized that in the code here, I have the convolutional FFT in the code. I think I'm actually going to split that out. So let's go ahead and move cd code Julia 1D convolution, and we're going to cd code Julia, and let's go ahead and move cp 1D convolution into convolutional theorem.jl. Okay, let's go into vi convolutional theorem.jl. Let's remove linear algebra we don't need. And let's just remove these guys from this code. And we're just going to go back into the main function here. Oh, well. Function main. Should be fine. And we're just going to do x and y need to exist, but we're just only going to do the FFT output for this one. Okay, right, quit. 1D Convolutional Theorem.jl. Oh, are you kidding me? That was not the command I meant. Okay, let's do this again. Sorry about that, guys. Delete that one. Delete all the way down here. Try it one more time. Remove all this, guys. Remove this. Perfect. Okay. This time we're not going to run the CP command again. I'm instead going to run vi 1d convolution.jl, and I'm going to delete fftw, and that's 5. And remove this guy and these two guys. Okay, so now I have to change all the code, but that's okay. So let me go up here. Let me catch up on chat just a second, guys. Let me just do set number. So it's 4 to 27 in here. So let's see. We should have a method, and we'll do 4 to 27. Yank for yank. 4 to 27. And then we have to fix all the other line numbers. 4 to 27. And I believe they're just -5 from what they were before. But we can check that really quick. All right, well, let's write that and see what we have. Isn't redshift completely due to space expanding, thus lengthening of wavelength of light? Well, you can see redshift in a pool, right? So I don't know. What was the question? You should know how a car gets super loud as it approaches and fades away. Redshift is that same effect with light instead of sound. Right. Are talking redshift like Doppler effect? Redshift is one of the relativistic Doppler effect. Yeah, it's related to the expanding universe. Okay, so I'm not... Okay, so we're all talking about the same thing. I thought it was just really dumb for a second. I saw some articles that some people use Compton scattering formula and couldn't understand why. Redshift is the Doppler effect? Right, okay. So let's just go to line 71. And the actual line here is going to be line 68. So that's going to be -5. No. 3? Okay, 68 to 69. I think. 68 to 69 for the cyclic convolution. Oh, no, I'm completely wrong. The simple linear is going to be 65 to 66. 65 to 66. And then over here is going to be 62 to 63. Okay. Up here, this was on line 35 to 54. It is now on lines... Oh, hello there. Okay. Set number is now on lines 29 to 50. 29 to 50. All right, we have to do that one more time for the method up here. And then that should be basically this section done with one last bit to talk about, but we're very close to being done with this particular chapter in the algorithm archive. Happy with that. So it was, what, 30 to 50? 29 to 50. To 50. Right, this? Okay, so that should build everything. Let's check to make sure the code is right. Convolve linear. Ooh. Oh. Okay. So it should be to 48, I believe. Rebuild that. And that is correct. So let's look for the next 50 and change that to a 48. Okay, so this should be everything done until the last section. Code's right, code's right, code is right. Now, that doesn't look good, so let's try to fix that up. Oh no. Ah, geez, if I change the code now, we're gonna have off by 1. It's okay. Let's just do it. Actually, okay, if this is seen on a modern browser, does that actually look okay on a normal browser? It will look fine on a normal browser, I'm pretty sure. I think it's just because the browser I was looking at, we'll leave it. I hate that it's over 80 columns, but we'll leave it. Okay, so we're going to quit here, and let's see what we have. So let me catch up on chat one more time, and then we'll keep going. I missed a lot of stuff. I saw some articles. Question about the FFT algorithm. I've been computing the spectrum from audio samples, but the FFT I'm using requires the power of 2 input. Therefore, I pad the samples I have with zeros on the right for the input. Are there any artifacts that this could cause? Also, to normalize the FFT output, do I divide the magnitudes proportional to the original number of samples or the proportional to the power of 2 samples? Do the power of 2 samples, I think, but also zero padding shouldn't cause anything, any changes. Like, it should be fine. So, like, for example, let's take this convolution here. Like, the convolution you're seeing here could have been done with FFTs, but essentially what you're seeing is 2 zero padded arrays. You have 0, 0, 0, 1s, and then zeros along here. The reason you need the power of 2 is just because of Cooley-Tukey method. In general, it works best with powers of 2. That's just what people do, so it's just faster to do powers of 2. But zero padding shouldn't cause any changes. Redshift expanding universe, but we observe blue shift also shrinking universe. No bright objects coming towards us. Yet blue shift is a thing. People actually measure how fast stars are rotating by measuring the degrees of redshift and blue shift. One side is rotating away and one is rotating towards. I think it's easier to do with galaxies and stars, though. If I recall correctly, it is moving towards you as a blue shift if away is redshift. As far as I know, Compton scattering is specifically an interaction between light and matter, QED, quantum electrodynamics, and matter isn't needed for redshifts. What OS are you using? Thanks for that, Amaris. Maybe there's something with underlying fields, but I don't know. If the object moves away, how is it related to the expansion of the universe? Can't we say an object is moving away instead of assuming the expansion? Thanks so much. That makes me feel more confident in my FFT code. Now time to figure out how to properly downsample with anti-aliasing. Good luck with that. It sounds like a pain. Right, so I actually don't know about redshifting on a galactic scale. I just know about it in, like, simple cases, you know, like when you look at a line at the bottom of a pool, you know, the black line, you'll see that it's red on one side and blue on the other, and that's the simple case of red shifting and blue shifting. That's about all I know. I'm gonna be honest, I've completely forgotten everything about anything at a like interspace level, you know. Okay, no, the code's fine. I wasn't gonna change the code. Okay, so let's keep going, and then we can read the last section here. In fact, let's go ahead and add the code at the bottom, and then we can read that last section, because that's kind of unrelated. So we're going to quit. No, we're not going to. Yeah, we're going to quit here. And then I'm going to open up tree traversal, move down here, and let me just take a look at the line that I used back here. Okay, so it's just import without anything. Okay, method. Here, yank for yank, G. And then in here, we should see all of the code for the chapter is shown here. DD. Okay, method, yank for yank, G, and all the code for the chapter is shown here. I think I can paste it here. Let's see. So for the full code, we have added a main function, that uses the convolution. We have used the convolution to generate a few files for the cyclic, for the 3 cases mentioned, a few files for the full convolution, and simple, and the periodic and simple boundary conditions discussed in this chapter. As a test case, we have chosen to use a random distribution for the signal, input signal, and a Gaussian filter. All right, we are so close. I think that's good. So let's go ahead and write that. There's one thing I have to do. Let me just put this at the very top, and we'll do that probably tomorrow. I'm just gonna add here to do. Make sure cyclic convolution works with, what am I going to say? Cyclic convolution works with large filter. Okay, we have to do that. We will do that tomorrow, I think. And now we can read the last section here, which should be relatively quick. It's just a quick example of multiplication as a convolution. So here it is, last bit here. As a final note to end this section, we will touch on a rather interesting side topic about how integer multiplication and convolutions are related. As an example, we will multiply, as an example, oh no. As an example, let's consider the multiplication of 1, 2, 3. Let us consider the following. Sorry about that. Multiplication. Okay. Let me catch up on chat, and then we'll keep writing this section. Thanks, non-Jerry Neutrino. I mean, every object is moving. Every object is moving away in every direction. That kind of implies that either the universe is expanding or we are shrinking. Yeah, as a guy who only knows Java to moderate levels, is there any benefit using Linux terminal for programming over other IDEs, or is it preference? Mainly preference. The thing is that galaxies far away are more redshifted than galaxies closer to us. The problem with IDEs is that it makes all the setup compilation tasks invisible to the user. Yeah, it's also hard to set up, and that step of setting up is always the most difficult thing to teach, you know? And so I figure let's just use things that are simple and like keep it simple. You know, it might be more difficult to use, but it's simpler, and I think simple is better. I say mostly preference. I prefer lightweight editors over IDEs for fast startup and customizability without all the bloat. Right. Of course, using an IDE or the command line is just preference. Right. For instance, thanks, non-Darren Neutrino. For instance, I used to use PyCharm a lot for writing Python code. Now I nearly only use a command line editor for writing Python. Right. I mean, I never really got into using IDEs. I didn't really learn how to use them, so I've always just been coding the same way. Like, this is the same setup I've had for years. And it's also the case that there are galaxies that are moving towards us currently, but the expansion of space is accelerating. So locally in time, we can observe a blue shift, but globally long-term, everything is getting further away from each other. Right. Okay, so multiplication as a convolution. Let me write this again, let it recompile, and then we'll read this section. This is actually, I think, a really cool section to end on, because it's something that it really helped me understand multiplication at a different level. Now, look, I understand multiplication. Like, I've done multiplication since I was in elementary school, but I still think this is cool. Okay, so as an example, let us consider the following multiplication. 1, 2, 3 times 4, 5, 6 is equal to 5, 6, 0, 8, 8. In this case, we might line up the two numbers like so. 1, 2, 3, 4, 5, 6 is equal to 5, 6, 0, 8, 8. Here, each column represents the power, represents another power of 10, such that the number 1, 2, 3, such that in the number 1, 2, 3, there's 1 100, 2 10s, and 3 1s. So let us consider, actually, I think those don't need apostrophes. Actually, I don't know, do they? Let's remove them. Okay, so let us use a similar notation to perform the convolution by reversing the second set of numbers and moving it to the right. By reversing the second set of numbers and moving it to the right, performing an element-wise multiplication and moving it to the right, performing an element-wise multiplication at each step. So here we're basically doing the convolution. We have 1, 2, 3 by 4, 5, 6. So it's reversed, and then we move it through. 1, 4 is equal to 4. And then after that, we have 0, 0, 1, 2, 3, and 6, 5, 4. So we have 1 and 5 lining up, 2 and 4. So 1 times 5 plus 2 times 4 is equal to 13. Then we have 1, 2, 3 lined up with 6, 5, 4. So it's 1 by 6, 2 by 5, 3 by 4 gives you 28. And then you get 1, 2, 3, 6, 5, 4. The 2 and 6 are lined up, the 3 and 5. And then, the 3 and 6 are lined up. And then we have a new set of numbers, 1, 2, 3 by 4, 5, 6 is 4, 13, 28, 27, and 18. Now all that's left is to perform the carrying operation by moving any number in the tens digit, tens, to its left-bound neighbor. For example, 4, 18 is equal to 4 plus 1. 4 plus 1, 8 is equal to 58. That doesn't make any sense. For example, the number is, I'm just going to put this in an array notation. 418 is going to be 4 plus 1, 8. which is going to be equal to 5, 8. I'm going to say 5, comma 8, or 58. So, for example, the number is 4, 18. Let's see what that looks like. I have to scroll down to the bottom again. Okay. So, for example, the numbers 4, 18 will be equal to 4 plus 1, 8, and then 5, 18. For these numbers, 4, 13, 28, 27, 18 will be 4 plus 1, because you're going to add the 1, 3 plus 2, 8 plus 10, and then you get 5 plus 5, 10, 8, 8, and then you move that over there, so it's 56088, which gives us 1, 2, 3 times 4, 5, 6 is equal to 56088, the correct answer for integer multiplication. I'm not going to go around suggesting that we teach. I'm not suggesting that we teach elementary school students to learn convolutions, but I do feel this is an interesting fact that most people do not know. Integer multiplication can't be performed with a convolution. This will be discussed in further detail when we talk about the Schoenhagen-Strassen algorithm, which uses this fact to perform multiplications for incredibly large integers. Cool. Okay, there we go. That's it. That is basically the entire text for the 1D convolution. Oh man. And we have the text mostly ready for the 2D as well. Like we're so close. I cannot express to you how long I've spent on this chapter. Like this entire week, I've been doing nothing but convolutions. So we have, the convolution intro. We have 1D convolution. This is a long chapter with a bunch of animations and visualizations and code and everything. And then we have the 2D and we have to do the same thing for it, but it's not as long. And then finally, convolutional theorem. Yeah. Cool. Okay. Let me catch up on some chat here. And it's also, wait. I feel like I missed something. I think I already read that one. Also, relativistic Doppler effect happens because general relativity does not have any energy invariance. Can't you also have RDE in special relativity? I don't know what RDE is. Oh, relativistic Doppler effect, right. A non-distributed, that makes sense. But if every object moves away globally because of the expansion, shouldn't the blue shift be impossible to observe? Doesn't the blue shift indicate that the speed of the object moving towards us beat the expansion rate of the universe? Okay, so what I'm going to do right now is I'm going to clean this up a little bit. So let's go into CD resources, Ellis here. There are a few of these that I don't need anymore, but I don't know which ones they are. MPV, 1D rand animation. What is this? This is one I can remove. So let's go ahead and remove 1D rand animation. Okay. Well, actually, I should have done git remove. Just in case it was here. Okay, what else do we have here? We need the 1D Gaussian, I believe. Let's just check them all. Let's just mpv star.mp4. Okay, so 1D Gaussian, we do need that one. Rand Gaussian, we need this one. Right. Rand Gaussian, 1D Rand Gaussian.mp4. I should probably rename that one. 1D Rand Gaussian simple. Sawtooth.mp4. 1D triangle animation, so we can remove that one. So the 1D triangle animation we can remove. Double Gaussian. And triangle square. Okay, so we can remove git rm 1D triangle animation. ls here, and the other thing I want to do is we have 1D Gaussian, 1D Rand Gaussian, and 1D. So I want to change 1D Rand Gaussian to, I think, 1D Rand Gaussian cyclic. So let's go ahead and move 1D Rand Gaussian .mp4 to 1D Rand Gaussian cyclic .mp4. Let me just, I think that's fine. So mpv 1D Rand Gaussian cyclic.mp4. Yeah. All right, let's change that in the text. We should be here. 1D.mp4, Rand Gaussian, and let's change this to be underscore cyclic. All right. And the last thing I'm going to do is write this, go over here, and rebuild the algorithm archive one more time just to make sure everything's good. And then we should be able to just, just make sure we have all the visualizations, everything's there, and it looks good. And then I'm going to call it for the technical part of today's stream. And we might do something else, or I don't know, we'll see. Let's see, what do we have here? Okay, convolutional theorem, let's go back. This one, we still have to do convolutions on images, but we're really close. I was thinking about doing Guild Wars. I don't know if people are into that or not. Let's see, playing with filters, everything looks good to me, right? Ah, that one. Oh no, are you kidding me? Periodic boundary conditions. Did I forget to write this? No, I did write it. Crap. Oh, I know what happened. MP4. Windy round Gaussian cyclic. Write that. I misspelled cyclic. Write that. Okay, let's see what we have here. Scroll down, and yep, still should be good. Wonderful. Okay. Example code. So we have to fix the example code down there, so that it reads in the entire file. So just import. Yeah. Okay. I'm happy that this is so close to being done. This is a chapter. Like, this is long. But and we're gonna have to do the licensing as well. So let's go up to the top and also say licensing. Okay, rank quit. Good. Okay. Git status dot cd backwind directory, git status dot I think these are all things that we need to add, so let's do git add dot git status. Okay, and we should have deleted a few files. Great. So we deleted 1D triangle animation, 1D Gaussian animation. Right, because we changed it to 1D Gaussian animation cyclic, 1D random animation. Okay, so git commit -m, adding, what am I going to say here? Adding draft for 1D chapter. Yeah, okay, git push, git branch, git push, upstream, origin, convolution, update. Okay. All right, let me catch up on chat, and then, yeah, we'll think about what to do next. Rather, when you launch a ball in the air with some initial velocity, for a while, a snapshot will show that ball is moving up, but our time eventually will see the ball moving down. Bubble isn't close to us when the local supercluster is not gravitationally bound. Okay, so I'm gonna have this visualization, the random visualization playing again. So let's do mpv out 29.mp4. Which one is this one? No, we want to do out 26. Sure, that one sounds good. Let's do this one. So I'll have this one playing for a bit. I'm going to take a quick break. Just going to go get a little bit more water. And I will be right back. Sorry about that, guys. So give me just a minute. And then I'll be back and we can talk about what to do next. For the record, I kind of want to do something non-technical today. It is Saturday. I think I might hop into like Guild Wars or something. I've been really enjoying the game recently. Get some water and grilled cheese. Man, I want some grilled cheese. I just don't have the right cheese. Like, the only cheese I have is pepper jack cheese. I think you could do grilled cheese with pepper jack cheese, but like, I don't know. It is actually, okay, it is actually reasonably, like, you could do it with pepper jack cheese, actually. Okay, I'm gonna be right back. Okay, back. Let's see. What do we have here? Get some water. It'd work out just fine. Dad's out. What's dad? What is dad? I've never had grilled cheese, mainly because I'm French. Yeah, there. You know, a lot of people have like very strong opinions about cheese in Europe. I do not have strong opinions about cheese. And I don't really know why people do. Okay. You are missing out, my friend. Grilled cheese and tomato soup is an amazing combination that I really wish people, you know, outside of the US appreciated a bit more. Okay. So, all right, give me just a second. Yeah, what would you guys say? What if I did play a little bit of Guild Wars for the next hour? Maybe that's what I do. Just play Guild Wars for an hour at the end of stream to kind of wind down. Not guaranteeing that people will enjoy watching Guild Wars or not, but we've just been doing such heavy technical content for the past, like, I mean, I took 3 days of break this week just focusing on convolutions. My brain is in a space where I need to kind of do something a bit different. And yeah, so grilled cheese is just, you take 2 pieces of bread, you put butter on it, and you just put cheese in the middle, and that's it. That's all it is. It's literally just bread, cheese, and butter. Crispy bread, butter, warm and melty cheese. Get some tomato soup in there on a cold, relaxed night. Yeah, that's exactly what it is. I'm telling you, tomato soup with grilled cheese is like, it is a wonderful combination. There are a lot of people who look down like on American cuisine, but you just don't look down on grilled cheese, man. It's amazing. All right, 1 second. All right, guys, I'm actually going to switch out from doing technical content. I realize, again, we didn't do very much last time on Guild Wars, but I'm actually going to switch to Guild Wars for just the next hour, just because I feel like playing it, and honestly, at this point, I'm probably going to, Okay, so what I was going to say is I was probably going to switch off from doing technical content anyway on stream, and then I thought, you know, I either close stream or I do a little bit of game streaming, and so I figure let's just do some Guild Wars and just, I don't know, maybe people will like it, probably not, but we'll see. Simplified version of croque-monsieur, isn't it? I have no idea what that is, so maybe? I do not have such a, I don't know how to put it. I don't have such a palette. Okay, so let me, yeah, let's do it. I don't know how to do this though. Should we do like an introduction to the game or croque-monsieur, I guess. Sorry, I should probably know how to pronounce that. Here, paste it in there. See what we got. There's no ham in a grilled cheese. And the cheese is in the middle, not the outside. Let's see, Guild Wars. Yes, a grilled cheese would be similar to croque-monsieur. Maybe. I say you play it and have fun. We're along for the ride. Yeah, okay, let's do it. So I'm just going to do something. I don't know what I'm going to call it. I'm just going to say non-meta builds for beginners. So non-meta for fun. Okay. Guild Wars to wrap up. Guild Wars. All right. Let's go. So we are now on the Guild Wars stream. Sorry if I spelled ham and butter wrong. Wait, a grilled cheese would be similar to a croque-monsieur, or I'm pronouncing that wrong. Could someone tell me how to pronounce it? I say you play it and we have fun and have fun. Sorry if I spelled ham and butter wrong. Wait, what? What? I'm so sorry. So let's go ahead and close up the shop from what we were doing earlier today. Lots of stuff. Man, I'm so happy we got that Convolution chapter done. Like, it's just like a feeling of relief knowing that we're done with that, you know? Well, not done, but like we're so close. We can see the light on the end at the end of the tunnel, you know? Jambon bière is ham on butter. Okay, so I'm gonna CD into games, Guild Wars here, and then I'm going to turn this off, go over here, run wine, and then it should be all set up, but just in case, I have a special keybind to move it into place, and now I'm going to do the following. Okay. And yeah, now I'm gonna go over here. Okay, so this stream setup is ever so slightly different than the stream setup you just saw a second ago. It is shifted down by just like a few pixels. So it should be that it looks almost the same. We still have chat on the side over here. But now you can see the game. One other thing I'm going to do is just bump up the volume just a little bit so you can hear the game as well. Maybe something like that. I don't really know the best way to do this because I don't normally do gaming streams. So we'll see. Another thing I guess I'm going to do is bump up the quality maybe just a little bit. Sorry, let me do settings. And I'm going to do the output and set this to be 3,500 kilobytes. I have quality options, so it should be okay. And we'll see what happens. Okay. I'm going to open up this and turn up the volume on my end. All right. And there's one other thing. I feel like, it's down. And let's drop this here. Perfect. Okay. Did I associate with playing Guild Wars? You play with one of my favorite board games? Wow, that's weird. All right, so I'm going to go ahead and play this character. Guild Wars 1, that's what we're doing. All right. I have no idea what exactly I'm going to do because there's a lot I could do. And I don't know. So we started playing yesterday. If there's something that you guys want me to do in particular, just let me know. The idea was just kind of to play the game, enjoy it, talk about why I like it, and all of this kind of stuff. And for the records, for those of you guys who maybe weren't here yesterday, the way I see Guild Wars is, again, as some sort of like, it's literally just a card game that you play in real time. And it's fun because it's just, you have all these different builds for all your different heroes. So like, here's my build for costs. And the thing that I do that I feel like most other people don't do is I really stick to this whole non-meta thing. Like I've actually set meta builds for the Paragon multiple times throughout my career, just because the Paragon is the only profession I play. And I'm not going to say I play them well, but there are certain builds that I've made that are pretty dang good. Like the Dagger Spam Para, which is currently meta. I'm actually really happy about that one being meta because I just kind of played it one day, and then all of a sudden I played it in PvP, and then it caught on in Reddit, and people started really liking it. And so there's been a lot of builds like that I just play for fun. I think what I might do is I might just go ahead and go to Lion's Arch, and maybe we just go through a mission at the end of Lion's Arch. Because there are 3 missions with this character I haven't done yet. I hate the notion of a meta. Just play what you ever want and have fun. Exactly. That's exactly my problem as well. See, the problem with Guild Wars right now is that there are, how do I put it? The people who are currently playing this game are people who have played this game for like the entirety of the game's existence. So I'm going to add, so that means that you have a lot of like really elite players playing the game. Who like really know what they're doing. But the big problem with that is, if you're going to have a game stay alive, you have to get like new people to play the game. And I would argue that these old players are doing a very bad job of like getting new people involved, because I think they don't know how to pitch it to people who maybe don't want to do speed clears or don't want to do like, that type of stuff. Like the game is still fun, even if you don't do like, the super end game content, and I guess that's kind of why I wanted to play it, just to see if other people think so as well. So I'm just going to put like a standard group of heroes on. Jorah is going to be what is Jorah? Jorah is a tank. She'll just take all the hits. I'm going to do, let's do Acolyte Jin, maybe. She's an archer. I'm also an archer, so, we're kind of doing the same thing. We have Acolyte Sasuke, who will do, or Sasuke, I guess, who will do the fire build, so he's just going to burn everybody. I'm going to add on Ogden, who's just heals everybody. We have another Ritualist, who also does a lot of healing. And then, let's see, who else do I want? I want Gwen, because she just, like, keeps the opposing parties from doing anything. She just interrupts everybody. Now, who else do I want here? Probably I'm going to add Livia, who's a minion master. So her what she does is she will like raise a bunch of enemies from the dead and create a whole bunch of undead minions. The last thing I'm going to do is I think I'm good to go. The last thing I'm going to do is change my gear. And let me explain why. Also, I'm just going to, yeah, anyway. So in this particular game, Sasuke super against his brother. Angsty. Yeah, maybe. So, okay, what am I going to say? So the reason I'm playing through this mission is I actually just got a new set of armor here that says Radiant Ancient Raiment or whatever. Now, the only difference between this armor and this armor is that this armor has been infused. And by that I mean certain enemies, called the Mersat in this game, they deal damage to you, and they have a particular skill that will just like kill you immediately if you don't have your armor infused. So I'm going to do this mission, and in this mission, part of it is getting the armor infused so that if I face these enemies again, they're not just going to completely demolish me. Favorite anime? My favorite anime is Koe no Katachi. Koe no Katachi. It's called A Silent Voice. It's amazing. I would definitely recommend checking it out. All right, we're going to enter the mission and just kind of go. We'll see what happens. So this guy's going to try to like sacrifice himself, but like, it's fine. We can actually just kill these guys. You know, he's supposed to do one of those things where he just like kind of runs away and like, you know, tries to lure the enemies away from, they already killed him. But anyway, he's trying to sacrifice himself so that we could like go further. But like, it doesn't matter. We're way more powerful than we're supposed to be at this stage because non-meta builds, man. So I'm just kind of messing around a bit. It's on Netflix. Honestly, okay, so Koe no Katachi is just an amazing anime. Because I don't know how to put it, but it deals with social anxiety better than any other anime I've ever seen or any other movie I've ever seen. It just does a really good job with, you know, just dealing with that kind of stuff. And I really enjoy it. Whatever. So I don't want to kill these guys, but I kind of like devoted myself to it. So now I want to do it. You know, like, what is he doing? Like, why is he all the way over here? I have no idea. So we're just gonna kind of get rid of him. Oh, you're obstructed. Cool. Okay, so we're gonna move up here, get these jade armors. Yeah, so again, the way my build works is I kind of use this focused anger in order to give myself like a bunch of adrenaline, and then I just kind of keep casting this Go for the Eyes shout, which basically gives everyone the chance to critical, and it also gives me energy. And so I just kind of mess around. It's not a great build. It's a build. It's fun. I enjoy it. So I genuinely cried when I watched it. Oh, I'm so glad you said that because like I thought I was a wuss. Like I love it so much. Did we pull these people? Was I just like not paying any attention? I guess not. It's fine. We're doing fine. Let's get this jade bow. Oh, where did you just die? But yeah, Koe no Katachi was such an amazing anime. Like, it was one of those things that, like, again, I feel like I don't know. Am I not hitting him? No, I am. Okay. I feel like I should have been, like, less emotionally invested in it. But I read the manga of Koe no Katachi, right? And there was a particular point in the manga where, like, essentially everything ended, you know? And it was like this dark like moment, and for some reason it decided to go on a hiatus at that point. And so I was sitting there for like the next month, because the manga only came out every month or two, thinking that the show ended on the most sour, like depressing note that it could have possibly ended on. And then after that, you know, we kind of realized, okay, it actually does get better. But I don't know. I'd recommend watching it. I don't actually watch too many movies or anything though, so maybe I should. But yeah, if you guys want to talk about anything, feel free to let me know. I might try to explain kind of what I'm doing in the game. If you want, I can explain the story. The story in Guild Wars, like, no one really plays Guild Wars for the story, but it exists, and I'm happy to spoil it if you guys want to hear about it. But I don't know if anybody actually wants to hear about it. Also, this mission I just remembered is a bit long. So what we have up here is something called an ether seal. So what this is going to do is it's going to drain all of my energy. So I don't want to be near that ether seal. It's going to drain my energy and just deal a heck of a lot of damage to me. And so I want to be kind of far away from that. On the other hand, Jorah can kind of be close because she does a lot of, what is it, like, adrenaline skills, so she doesn't really need to deal too much with energy. So I'm going to go ahead and proc these guys, and then I'm just going to attack the Ether Seal and see how it goes. So you'll see that's kind of the boundary, so I'm right on that boundary. Jory, are you going to do anything, or are you just going to... I played Guild Wars 2 for a long time, and after an update, Necromancers became OP, literally broken. Lots of DOTs with huge damage, and to counter them, Guardians became a thing. All of the classes, especially Elementalists, became dead. Then they introduced elite specializations, and playing Elementalists evolved into playing Flight of the Bumblebee piano piece as Weaver. Then I installed the game. Probably should be paying attention to this battle, because we are not able to get down the Ether Seal, apparently. So let's regroup, and let's go back and try this mission again. So let's see. I'm zoomed out just so I can see everything. Like, your character doesn't matter too much in this game. So they introduced elite specializations, and playing Elementalists evolved into playing Flight of the Bumblebee piano piece as a Weaver. Then I uninstalled the game. I don't know how recent balances are. Has Guild Wars 1 broken classes? I don't think Guild Wars 1 has any broken classes. I mean, I think every class, every profession has a build that works pretty well, so far as I'm aware. So I don't think anything's actually broken. I would say that the Mesmers are kind of a bit overpowered. But as far as Guild Wars 2 balance is concerned, I think you're talking specifically about the Scourge, or whatever, when Path of Fire came out. And yeah, I'm with you. When PvP, I used to play a lot of PvP, and when Path of Fire came out, I played a lot of, what's it called? It's a specialization with daggers on the Spellbreaker. And I really enjoyed Spellbreaker. It's a class in Guild Wars 2 that's entirely dedicated to shutting down the opponent, but you do it in melee range, and it's kind of fun. But the reason the reason I liked that particular character, or that particular profession, was that there was a particular skill called Sight Beyond Sight. And all it did was unveil people who are stealthed. And honestly, in my opinion, stealth should not be in a game. Like, if stealth kind of just makes the game a bit, I don't know. I don't like the idea of stealth in games. So I'm kind of against it. And so Guild Wars 1 didn't have stealth, and it doesn't have like these kind of cheap mechanics, like, that type of stuff. Again, stealth is one of them, but also another mechanic that I think is relatively cheap is, aren't they supposed to be following this guy? Yeah, okay. Another mechanic that I think is relatively cheap is, like, for example, what's it called when you grab, like, the enemy's aggro? Taunting, for example. By the way, Karshi, no, thank you so much for following. Really appreciate it. Okay, we're just gonna kind of do our thing. I'm gonna close chat so you guys can see that. And so you'll see here that we have some jade armors up here and some jade armors over there. So we're just gonna get these guys. I guess we want to go for the jade bow. And this time, we're going to actually try to get down that Ether Seal, because I apparently did a very bad job of that before. And I now know we should be careful about that. I think we're going to aggro this guy. We're very close. We're definitely going to aggro these guys. It's okay. Again, the Ether Seals are a big deal. The Mersad are pretty easy. So we're okay. But yeah, if you guys want to talk about it, just let me know. I'm happy to talk about this type of stuff. And also, like, the difference between Guild Wars 1 and Guild Wars 2, like, if you guys want to talk about that as well, I'm more than happy to do so. I personally prefer this game to Guild Wars 2, but Guild Wars 2 is a great game, and I definitely recommend playing that as well if you're into, like, more of a, I don't know how to put it, but like a traditional MMO playstyle, I would say. Okay, so now we have to get this Elementalist, because we also aggroed them. But I feel like this game's more of like a, again, if you think of it like a card game, it actually plays particularly, like, I enjoy it as like a live action card game. And that's really how I think about it, and I very much enjoy playing it that way. Meanwhile, Guild Wars 2 is not really that, right? It's more of a it's more of like an action game, you know. I've really enjoyed the stream so far. Both the Convolution work and Guild Wars 1 perfect background noise while I work on my own code. Yeah, thanks so much. I appreciate that. We'll be doing more technical content again tomorrow. Again, I am burnt out with the technical work because I've just been doing convolutions all week. So we grabbed these guys as well up there. They're coming in, but that's okay. It's not a big deal. But yeah, if you guys, I don't know. I don't really know what to say. So we should probably want to get the Elementalist before the Mesmer. I don't really remember which is worse for Marsat, but it doesn't really matter. Again, Marsat are super easy to take down. It's just that Ether Seal up there that I don't like. It's okay. Again, I'm gonna switch builds if we end up failing this one more time, because this isn't a hard mission. I've done it many times before, but I think just the act of streaming and also like playing the game, I think kind of got me a bit. So I'm gonna grab my longbow and I'm just gonna grab the jade bow and I'm gonna bring them over here, and then we're gonna get the ether seal last. So these guys will then come this way, and we should be able to attack them over here. And then we'll just grab that ether seal at the end. Well, or not. I thought they'd come up, but apparently they don't want to. Come on. Oh, come on, man. All right, we'll get this guy. That's fine. As long as we get one person, it's okay. OG Guild Wars, I have so many hours in this game. Dude, yeah, tell me about it. All right, we're going to go back for just a second. And then I think we can take down the ether seal if we all just focus on it. In other MMOs, stealth is usually not OP because some items or skills that break stealth. But in Guild Wars 2, I saw a build that with pistol someone became perma-stealth, very cheap. Yeah, again, Guild Wars 2 is a great game. I genuinely enjoy it for like the breadth of movement that you have as a player. Like you have mounts, you have gliding. It's great, honestly. But I don't very much enjoy it for, you know, how do I put this? I don't like it for the skill variety, right? Like I like this game for that type of stuff. Started playing Guild Wars 2, Guild Wars 1 like 4 years ago. Started in 2006. So let's try to get these jade bows down. And Guild Wars 2 for some months. Yeah, no, Guild Wars 2 is still good. Like it's a great game. It's just again, for me in particular, it just wasn't for me. I have lots of time in Guild Wars 2 as well. Like, honestly, I did, like, a check with my character, and apparently I have, like, 600 hours in Guild Wars 2, which is absolutely insane. I never thought I had that amount of time in the game. I don't understand how, either, honestly. Let me just do F4, so I'm switching to a shorter range bow, and then we should get all these guys to, come on, attack the ether seal. I think what happened last time is we just weren't close enough to get the ether seal attacked. But we'll see. Ooh, this is not good. All right, let's go. Do we not have enough damage to take this down? Are you kidding me? All right, well, apparently I chose characters that can't deal any damage, which is weird to me because I just finished like the end game prophecies stuff. Well, I mean, not like hard mode, but we'll see. I prefer Guild Wars 1 by far. I still remember my main character name, but email is inactive. Oh, wait, so you can't log in anymore? Even, probably because support, yeah, okay. That's the unfortunate thing. The ArenaNet devs kind of like, they really care a lot about Guild Wars 2, and they don't care pretty much at all about Guild Wars 1 anymore. This talk with Pat Wyatt, ArenaNet founder, who did a bunch of network architecture for Guild Wars and old Blizzard games, is fascinating. Oh yeah, they did some amazing stuff with the Guild Wars architecture and everything. Why am I so bad at this? Like, honestly, like, did I pick no one that can do damage? Whatever, it's fine. Let's see. Botez Live rated a streamer with 3 viewers, with their 30K viewers, but he got a bit nervous, no mods, so obviously he had to turn the chat to emote only after some time. Then chess.com contacted him live on the website where he was playing, telling him he is a professional streamer now, and gave him a lifetime diamond membership. Interesting. The server uptime for Guild Wars was insane. They will send you a link to reset the password. Oh, okay, yeah. But that's actually super cool. I'm happy to hear that. Again, we're just kind of playing casually. I'm not trying to do anything crazy over here. Also, I don't really remember how to play this particular mission. I'm kind of going in blind. Worst case scenario, we can just open up the wiki. So that's the other thing about the game. The wiki is actually genuinely enjoyable. Like, or it's like a great resource for new players that a lot of people don't really care about. Wait, holy moly, what a lucky guy. What did you say? Okay, so let's go up here. We're going to get these guys as well. Again, my primary goal for doing this is just to get the infused armor. I'm still gonna finish the mission and all, but you know, the infused armor is kind of the big thing here for me. Oh, that was a mistake. That's okay. We're just kind of, I'm not even really playing at this point. Like, this is the thing about Guild Wars, it's so team-based, that you don't really have to care too much about what you individually do, but you have to make sure that you're not. Like, for example, if I really wanted to play this game, like, and try hard, I would switch my build to, like, a meta build, like the Imbagon or something like this, but I'm not going to, because I just like playing non-meta builds. That's what I do. What do we have here? I turned off to get rated when I stream. I'd be too nervous. Yeah, I want to do that sometimes, because sometimes I'll be like ending a stream, and then all of a sudden, like, you know, I'll be rated, and I'm like, well, I was gonna end stream, but now, you know, I can't exactly do that because we have, you know, this new person. So this person will start the bonus. He's an ancient seer. Yeah, it's not too bad. So I'm just going to go up here because there's an Etten boss who's pretty easy to beat. And so just to get an extra +2 morale boost. So, okay, let's grab that. Yeah, this is easy. Let's see, what do we have here? Can you still do 55 HP solo? Yeah, you definitely can. In fact, you know, here, oh, come on. No one interrupted? Thank you. I've been thinking a lot about, like, a Paragon 55 build. I have a Paragon MM build, and I've been thinking about, like, trying all the meta builds except, like, doing a Paragon variant of it, just for fun recently. I don't know, Paragon's what I play, so. But yeah, the 55 build, for those of you guys who don't know, was a particular build that they had with the monk profession. And the idea with the build was that you limit your HP to 55, which could only be done with a particular set of armor and a particular weapon. And then you used a skill that said you cannot take more than 10% damage. So everyone could only deal 5% damage to you. And if you have a bunch of regen on your character, so you're gaining, like, you know, you have 5 pips of regeneration like you have over here with energy, except with health, you're going to be gaining so much more than 5 per second. So you're basically not able to die. Like, it's very difficult for you to die with that build, unless people remove the enchantments, which was something we talked about before yesterday. I don't even know the game. Looks like WoW. So it's like WoW, except, again, the difference here is that I think comparing it to WoW is a bit... I would not compare this game so much to WoW, is what I would say. Again, I compare it more to, like, Yu-Gi-Oh! or Magic or something like that. That's how I compare it. Because the whole point of the game is just to, like, just make interesting builds and stuff like that. Now, the gameplay, I suppose, in some sense, is a bit like WoW. I'm going to try to just pull these guys over this way. I think if I move them on this side and I grab the longbow, I can pull them over. Ooh, that's going to be a bit hard. You think I can? Maybe. Are they going to run this way? Are they going to go through the lava? Looks like they are, but they're not damaged by lava. Of course not. Yeah, of course they're not. Okay, well, just whatever, doesn't matter. Nope. So lava's gonna kill, like, all of our minions, which, whatever. Alright, so now we're gonna have to get through, which is gonna be fine. So I'm just gonna flag my parties over to the other side and give them fall back, and we're just gonna go. But yeah, okay, so comparisons to WoW, right? Like, the big difference is that this game, you have instance gameplay, whereas WoW, you don't really have instance gameplay. So we're just going to go ahead and kill this guy up here since he took no damage. Whatever. Well, let's pull him. And then bring him this way. Come on. All right, there we go. So just had to make sure he was outside of the ether seal. So yeah, in this game, like, if you kill an enemy, they're dead for good. Like, they don't come back, which is really important because, you know, you're going to be out adventuring with your party and everything. And I don't know, it has a bit more, like, of an emphasis on, like, tactics. So here, like, I really care about this group over here, and, like, I care a lot about pulling and stuff like that. I'm not saying you don't do that in Guild Wars or in in WoW, but I'm saying that like the emphasis is different. Here, it's not so much about exploring the world. It's more about, are we? It's more about, you know, creating builds and stuff like that. Before the expansions, I ascended a character at something like level 2 or 3 and jumped to 10 levels. Wasn't practical at all for power leveling though. Had to have friends run me through a bunch of missions. Wait, what are you talking about? Let's get these jade bows for Pete's sake. So you had a character in this game that was just like level 10 and you just kind of like had him rush through. What is Jin doing? So does Jin have a bow? What? Why was she so close? I don't understand. All right, so we're gonna let ourselves regen up a bit. Let's see. Right, the world really doesn't look like high-end graphics. Oh, okay, just get the freaking Ether Seal. Yeah, this is a 15-year-old game. Like, I'm not gonna say it's high-resolution graphics. Like, again, you don't care about exploring the world so much in this game. It's more about like, just, I don't know. Making fun builds and that type of stuff. So, and you don't really care about the storyline either. Like, it's a very specific type of gameplay. Okay, I have no energy, and I don't really have any other games to compare it to because I just genuinely don't think there are other games that you can compare with. I'm gonna skip this cutscene because I just don't care about it. I know it's what they're going to say. Like, they're going to say we shouldn't go through the front door because it's, you know, jam-packed with people. And I think at the rate at which we're killing people, I think that's probably fair. Like, we should probably take that advice with a grain of salt. So we're going to take the back route, which is a safer strat, but whatever. But honestly, for a 15-year-old game, I think the graphics do hold up pretty well. In a lot of ways, actually, like, this is like the very first campaign that they ever made. Like, this is the end of the first campaign, right? And they did a lot better with the later campaigns. So I guess my point is that, like, you know, in some places in this game, I would argue that they did better with Guild Wars 1 than they did with Guild Wars 2, in terms of just, like, how the game looks and stuff like that. Again, I am a bit biased, so I don't know if that's exactly true or not, but for me in particular, it feels like the Guild Wars 1 game was a bit more, I don't know, I feel like more, I know it wasn't more effort, but it just feels like more effort. I don't exactly know why. Maybe a bit like Final Fantasy, there was still development tree and different spells, etc. Right, again though, it's deck building. Like, it's, I wouldn't compare it to any game like that because, am I not able to kill a lava splitter? You kidding me? I wouldn't compare it to those games because the whole point in this game is just to make, we pulled. Is just to make weird builds. Like, that's the whole thing. For Ascension, I was talking about the mission at the end of this area. Yeah, I figured that's what you meant, which opened up the secondary class and then gave ton of experience, right? So we're just gonna get this guy. Yep. I don't know why I keep using this skill. That skill doesn't matter. That's the one that matters. So this guy's a monk and he's healing himself, and like, I'm just doing a bad job. Like, I'm not playing this game very well. That's okay. I got a holy rod. That's fine. We'll just grab our holy rod and go. But yeah, I think a lot of people, again, my fear with this game, and what I feel happens a lot, is that the people who play this game are predominantly people who have been playing this game for ages, you know? So, this is gonna suck, isn't it? George, attack this guy, please. Would you? Okay, or not. Yeah, whatever. It's fine. I got it. Oh, no, I don't. Oh, you kidding me? Okay, whatever. We got it. It's fine. Nothing matters anymore. But yeah, and my hope is that, like, at some point we can just get new people to play the game. Like, that's kind of all I'm hoping for. Because I think the game is genuinely fun. And again, like, there isn't another build system out there like this one. Which is why, I don't know, I just... Like, so the way it works, again, I explained this yesterday, but each of your professions have a primary and secondary attribute. So your primary attribute for me is a paragon. So that means I gain, you know, a special energy anytime that I I cast a shout. So that's why Go for the Eyes is such a nice shout, because it means that, oop, I should have interrupted that. But it just means that every time I use it, I just get a bunch of energy back. And then I can use any other skill from any other profession in the game. And I just don't know of any other games that do that. Are you kidding me? We're just aggroing like crazy. It's like I'm not even trying. And the lava splitters are just... oh well, that's okay. I see you do stream games. I got an ad as well. Sorry about that. All right, we have to get these lava spiders up here. I actually just now started streaming games. I usually don't. So this is like, I think the second stream I've ever played a game on stream. This might be a long mission. I'm realizing that we're doing like no damage output. And honestly, we have to do something with their Drider's defense, because they keep blocking all my skills and it's kind of a pain. Yeah, so this is blocked. And okay, so we got that. Let's go back here. I didn't realize that these guys were so annoying to fight. Are you even trying? Not really. I'm just like, I'm failing. Like, that's what I'm doing. It's okay. All right, good. So who's this guy up here? This is, what just happened? I don't know exactly what happened, but I just canceled out of the game. So, well, that's it for now. We'll open it up again and we'll do something else. Because I'm not doing that again. Whatever. My bad. Ah, dang it. We were so close. We're locked out of the skills, and you were locked out of the skills and the game. Okay, so I didn't do Alt F4. I pressed Alt and space. Can I replicate that? How did that happen? I actually don't know what I pressed to do that. My brother has a real Yu-Gi-Oh deck and likes such games. I should ask him about it. Looks like he has no video where he played it. Space is equal to F4. I don't know what just happened. It just kind of closed on me. I don't really have enough time to go through this whole mission again, especially not with the damage output that we were doing. Press Alt. Pressed Alt. I saw a menu on the top left. Oh no. G. A menu on the top left. I don't know. Maybe I did Alt Space. Oh, okay, I see. So I pressed Alt Space, and then I moved around in Guild Wars, which is doing some really weird things for some reason. And then somehow I clicked maybe off the map over here. And I must have somehow moved to close. Somehow. I don't know how. That's what happened. I somehow hit this close button on... Oops. Well, here we go again. G. Well, hello. Probably Cosmic Ray flipping, bit flipping, causing a crash. Hey C252, how are you? Is it running with Linux? It's an interesting... That's interesting for such an old game. Yeah, it's running... I mean, Guild Wars is one of, like... I think as far as, like, wine is concerned, Guild Wars is, like, one of the best games that runs with wine. It's, like, considered gold, maybe even platinum. But yeah, it's definitely wine. I mean, here, let me... I'm going to go to another area because... well, maybe I'll just try a different build. Or... This mission's just going to take a while, and it's such a long mission. All I wanted to do was infuse my armor, and I don't really care about doing that too much right now. So, maybe we do something else. What else is there that I actually want to do, though? Let me travel to Kining Center. I could try some PvP, and see how that goes. Let me see. So I just... Oh, people are going to hate my build if I do it. Let me go to Fort Aspenwood and see if anybody's here. Yeah, party's too large. There are people here, so I could technically do Fort Aspenwood with my really crappy build. I don't normally play Fort Aspenwood, but, you know, we'll see. I tried League of Legends once in Wine, but it didn't run, and now that they've introduced their Windows kernel driver for cheat detection, I guess it'll be even more complicated. Yeah, I never was able to get League of Legends working on Linux. I was not once able to get it working. Let me mess around a bit, and let me grab my heal dagger build here, load that, and let's just see what happens, you know? Like, what's the worst that could happen? So, I need a little bit of practice playing this build, though, because I haven't done it in a while. So maybe we... I need to think. Let me go to Lion's Arch and let me think. So I have, there's another thing that I could do. I could do the bonus on Iron Mines of Moladun, which would give me the same infused thing that I needed, and I could just try my my dagger spam build while kind of messing around with that a bit. The truth is that Iron Mines of Moladun is also very long, and I don't remember what the bonus is. So let me just pop over here and let me do Guild Wars Wiki. And let's see what we got here. So, Iron Mines of Moladun. Oh, they do run long. Interesting. Cool. Okay, so what is the bonus here? So the bonus is defeat the Inquisitor before he leaves with the information about the Shining Blade. Okay, how do I... So for the bonus, the Shining Blade Scout Rider urges players to kill the Inquisitor before it escapes with intelligence. Accepting the bonus will spawn the mentioned boss and a few Mursat, which will move north towards the Mursat teleporter. To get to Ryder in the first place, head south of Marcus and kill the Mursat you encounter. We could do it. I mean, why not? I feel like I don't remember how long. I remember this mission taking a while, and I don't remember why. So maybe we just go for it. Duration medium long. Yeah, where is there a duration? It says duration right there. I didn't want to do a long mission. I was hoping to do something kind of short. And I just finished all of... Do I have any quests in my log? I don't really. Let's see, what else could I do? We could also just do some bonus missions. Let's see, what do we have? I could work on some titles or something. Or I could just play some PvP. You know, and people are going to be pissed off at my bad build. And that's fine. Like, it's okay. Like, I don't mind too much. So one thing... Yeah, maybe that's what I do. Maybe I just do some PvP. People are going to be pissed off, and that's okay. Right? Like... Yeah, people are just going to be pissed off at my bad build, and we're just going to go with it. I don't care that much. So let's go here. I wanted to try... I actually, like, don't even know if I remember how to play Fort Aspenwood. But there seem to be people here. So I'm going to just enter battle, and we're going to see how this goes. And if all of you guys see that I'm, like, just noobing it up, and you guys, you know, can't stand, you know, like, watching anymore, I guess that's fine, you know? Oh, wait a minute. I gotta cancel really quick. Marches in, hit enter to queue up for the next one. Wait, what is that? Oh, they're talking about to make sure that we can actually play the next match. This is only doing 51 health? Okay, that's fine. Let's do it. Well, I'm really nervous about it. All right, let's just enter battle and let's go. And we'll see how this goes. Usually what I do is I give days on this build also, and switch back and forth between my spear and my daggers. But I don't know, I just installed Guild Wars and logged in, forgot I have a level 14 character in the tutorial area. That's actually super fun. The timer reset. But yeah, this is a very basic PvP match, I think. So, I mean, I can like bump up my companion of the Luxons or whatever. I'm actually not sure what I should be going for here. There's a lot of different titles I could go for, but again, maybe I could just make another build. Well, let's try playing this a bit, and then we'll try a different build or something. I don't want to go too far past 8 o'clock today. So I know I'm not really doing anything, but now I feel bad because I should be doing something. Well, let's see if there's... Oh, I really wanted to infuse my armor. Is there a better way to infuse the armor? Let's see. Infusion. Okay, what do we have here? There's locations here. So we have Iron Mines, Ring of Fire, Abaddon's Mouth, which I think is also a long mission. It's a long mission, yeah. And then we have Mineral Springs. So maybe I try Mineral Springs. I've never actually done this before. What time is it for you? It's 7:30, so I was going to do for maybe another 30 minutes. Yeah, actually, let's exit Tasca's Demise. So, the Granite Citadel. So I have to go through the Granite Citadel to Mineral Springs. Why is this so Like, why is this so hard? All right, fine. We'll just go back to the mission we were at before. But that one's also long. Ah, I want to do something short. Um, well, um, I was thinking about maybe making a new build, so maybe we do that. Um, so I was thinking about a long time ago. I made this really dumb build. Hear me out. I don't remember what the build was, but a long time ago it was. I'm gonna pull up. I use Arch, by the way, and I'm just gonna have him be the model. So he was also the model for my bow build. But a long time ago, I made this build that was all it did was extend conditions. So let's do Paragon Mesmer. And then I think I used extend conditions, which was, where is it? Probably illusion magic? No, maybe inspiration? Here. Where is it? Ah, here it is. So extend conditions is an elite spell. It spreads all conditions from target foe to all foes near your target. The durations of those conditions are increased by 5%. So a long time ago, I made a build that I went through all of the Guild Wars 1 campaigns with. It was it was, prophecies, factions, and Nightfall that was reliant on extend conditions, and for some reason, and I don't remember exactly why, spear swipe. And so I think what I did is I just ran up to them and I just gave them all dazed, and that's what I did. Oh, side note, I kind of want to show off my favorite build that I've ever made, but is definitely not meta. Here, let me go there. Just really quick. There was this one build I made a long time ago that was super fun to play. Here's Zeph. But it's definitely not meta. Yeah, here it is. I'm actually holding it right now. So this build got me through everything. A whole bunch of hard mode content. It's such an amazing build, and no one knows about it. So I kind of wanted to explain how it works, just because, I don't know, again, it's a deck building game, and it's fun to talk about. So the way this works is I put down this one skill called Fever Dreams on everyone in the area, right? And basically it says foes in the area also have any new conditions that target foe acquires, and it inflicts dazed on the target foe if that foe has 2 or more conditions. Now, maybe it is meta. It's been a long time. But the thing that's nice about this one is that it inflicts a dazed condition. And dazed is a really, really nasty condition. What it does is it means that if you're a caster, you're casting spells, you will take twice as long to cast skills, and you can be easily interrupted. So that's why you don't want to have dazed, right? It's kind of like you don't want weakness if you're a melee or a martial attacker. The next thing I do is Fragility. It's a hex spell and also hexes foes foes adjacent to the target, and those foes take 18 damage every time they gain or lose a condition. So obviously these two work very well together because you're giving conditions to everyone, right? So that's simple, right? The next thing I do is Shrinking Armor. It causes -4 health generation, and it inflicts cracked armor. And then I give them, I do Drain Delusions, which will then remove that, thereby giving them cracked armor and giving everyone around them cracked armor. I then give them Bleeding with Barbed Sphere, and then I give them Deep Wound if they have cracked armor. And at that point, I'm basically pumping conditions out on them. And then everyone else in my party is also very heavy condition damage. And so, I know it doesn't sound that great. I think it was different a while ago because I think these two skills were different. But you basically just pump conditions on them, and then you just see everyone just kind of melt. And it was a lot of fun to play. It's one of my favorite builds I've ever made. The other super fun build that I made, let's see, load. Do I have it? Oh, I don't have it anymore. But it was a build that basically stole all of the builds from other people. So every skill was basically stolen from another player. And that was kind of what I did. It was a lot of fun as well. Okay, I'm gonna go back to my Paragon now. Sorry. I was gonna make a build. I'm sorry it's so scattered. I really don't know what the best thing is to do on stream. I was gonna go through the whole mission, but since we kind of failed at that one point, I don't remember what happened. Did we die? Oh no, I accidentally quit out. That's what happened. I accidentally closed out of the player. I don't know. Maybe I just close it for now. I tried. So whatever. I'll come back maybe later. I'm not sure. So the thing is, I'm not actually sure if you guys enjoy watching people play games. I definitely don't usually watch people play games. The exception is Guild Wars. I watch people play Guild Wars. and every now and again I'll watch like Wooden Potatoes or something, but I don't usually do so much in terms of just like watching people play games for hours. And this one in particular, like I was just playing through with my friend earlier today, and so I don't want to progress my storyline with Eye of the North. I do kind of want to do some PvP, but I don't know, I'm kind of not in the mood to do PvP right now just because there are people watching and they'll see how bad I am at it. But maybe that's part of the thing. Yeah, maybe it's okay. Maybe it's fine. Let's just try to let's try to do PvP. And we'll see what happens. And in fact, I'm gonna do log out, character select, and I'm gonna play as, I use Arch by the way, which should already have the dagger spam build already built in. No, it doesn't. Let's do load. Dagger spam, para. No, I want to do heal daggers. Okay, and then we should be able to switch to these guys. And yeah, let's go to Great Temple of Balthazar. And you think I could do random arenas? I use Lion's Arch, by the way. Wait, what's sorry about that. Maybe I should know. Let's do 4 Aspenwood. Ready to go, and let's just see how bad I do. I'm not gonna say I'm good at this game because I'm not. But I do have a lot of time invested in it. Let's always hide except PvP. Should be fine. And let's just see what happens. We're gonna have to wait for this timer to kind of. The thing is, the game's old, and there aren't too many people. Oh yeah, Lion's Arch, Lion's Arc. I actually don't know how to pronounce it, but yeah, it's definitely a place in the game. So the game's old, and you know, because of that, it doesn't actually have too many people playing PvP. But honestly, the Guild Wars 2 PvP, Guild Wars 1 and Guild Wars 2 PvP is genuinely fun. I'll try to move that down just like 1 pixel. Okay, that maybe worked. It's kind of hard to find people that play nowadays because it's just hard to find people that play, you know? So that was another reason why I wanted to stream it, because I just kind of wanted to see if we could get more people involved, you know? See if they, if we could get people to, you know, enjoy the game and stuff. So I honestly don't even remember what 4 Aspenwood is. So this is going to be really interesting because I think we're just going to fail miserably. And I'm sorry about that. So I'm going to go with these guys over here. Yeah, I think that's what we want. I see that Guild Wars was never about the number of skills. It's about how, it's not the number of skills, it's how you use them. Oh gosh, I'm nervous. I'm really nervous about this. Also, what are these guys doing? Should I be in chat? No one said anything. So, I switched to a real build. Oh no. This is going to be interesting. We'll see how it goes. I'm just going to play. There are a few other streamers in the Guild Wars category, 31 users together. That's fair. Well, we have like, what, 27 right now? So that means that we're kind of most of them, right? Okay, so we should be able to do that. And let's see what we have to do, because I don't know. I'm just kind of following. I wish I knew what I was doing. Okay, right. Okay, this is going to be rough. It's going to be super rough. I'm just kind of attacking. So we have the Mesmer, and we have the Monk. So I want to get the Monk, I think. So we're just going to do this and that. And then we're just going to just go. Just see what happens. Oh, she's blocking. Great. Yep. Okay, so maybe that wasn't the best idea. Okay, we got it. I think I'm doing this. Oh, what? Oh, all of the recharge times suck in PvP. They're different. Okay, that's not great. Okay, well, I didn't realize the recharge times were worse in PvP. That would have been nice to know. Okay, this is okay. We'll get there. One step at a time. Oh no. Okay. Well, that's something. Most viewers are here, probably not Guild Wars players. That's true as well. I guess we're just gonna get this Mesmer. Again, I really don't know what we're doing here, so I'm just kind of messing around. Yep. Let's see what happens. Is there a monk around that's healing him? There must be a monk around. Cursic Necromancer. Oh, up there. I see what's happening. Right. Of course that's happening. Let us maybe run away. I don't know. But let's get the Necromancer then. I guess, since he's getting after the Necromancer. I'm missing, and I'm being hit. So this isn't working out, I don't think. Yeah, of course I don't have enough energy because I haven't been able to use my shout. Okay, I'm just doing very bad. I'm sorry about that, guys. I actually don't even know what I'm doing, if I'm being honest. I just use fallback. Okay, well let's just run away then. Since I have fallback on me. I don't know what I'm doing at all. I'm so sorry. I suck at this game. Well, we got one person down. The Necromancer then. Oh gosh. Well, that's okay. At least game can play. Yeah, I'm playing it on Arch Linux right now. I'm gonna get the assassin now, I guess. I wish I could play this game, but I used to be good, and now I can't. I don't even know where my allies are. Oh gosh. Okay, let's just go back then. We're gonna get the Elementalist. Because I suck. Okay, let's just see what happens. Okay. Necromancer then? Okay. I'm missing everything. Well, this is Guild Wars, guys. I can't even install simple programs. I'm sorry, I suck at this so much. Sorry. I'm just gonna say, sorry. I'm gonna say this, and they're gonna be upset, and that's okay. Let's see. At least really not for games? Not usually, no. I was hoping that this guy would come along with me. So here we have an Elementalist. Let's just do this skill and that skill, and then we're just gonna kind of see what happens. Because, you know, I really don't know what's gonna happen. Yep, this isn't working. See, this works okay in PvE, but it definitely doesn't work in PvP. I'm learning the ropes here. And that's okay. So maybe I'm gonna use fallback and we're gonna die. That's okay. I have no idea what's going on, so it looks like you're doing great. Thanks, considering I'm dead. I actually don't know what's going on either, if I'm being honest. I probably should know, but I really don't. So... Oh, this guy. We could kill that guy if I just had a ranged weapon, which I don't. Because I decided to do dagger spam. Oh, man. I'm sorry. Where's he going? Oh, he's going up here to the mine cleaner? Yeah, let's do it. Why not? Oh, maybe he could deal with them on his own. Whoops. Am I not dealing any damage? Okay, this is fine. We'll just keep going. Yeah, we don't have any damage. I'm sorry. Wait, where is the allies? Where is everybody? Who's this guy? Okay, so just fall back, man. Like, it's fine. Okay. Well, I'm a bit lost. I'm sorry, this is a bad decision. But it's okay. Life is about making bad decisions and learning from them, I think. Because at this stage, that's about where I'm at. Okay, so we have this guy. I want to get away from that. Okay, let's do this. And now we're just going to do that. And I'm going to just, I don't know what I'm going to do, because I do no damage. So let's just get this Kurzik Elementalist since they're dead. This guy's in. That's not gonna work. Okay, that's fine. Yep, this is okay. I'm just gonna run away now. Alright, let's just go. Okay. I'm so sorry. Oops. It is what it is, you know. Okay, well he's gonna keep blocking, so there isn't really much I can do about that. Oh well. Let's just go. Okay. Do 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 do. Yep. This is me trying to play a game. At least I got him. That's something. Oh man. That's, you know, kind of completely my bad. Oh well. What do we have? I think we should go a bit further in. I think, but I don't exactly know. So let's just try, I don't know what to do, but maybe we just try this guy. And I just cast this spell, and then I just go here. This isn't gonna work. Yep, I'm gonna die. I suck. I'm really bad at this. I'm gonna run away. No, I don't have enough energy. So, right. Yep. And my healing skill only works if I'm attacking. So because of that, I'm gonna reckon that I should have chosen a different skill. Okay, let's just do resign as well. And I'm happy to just go. I'm gonna go after this. Oh, for Pete's sake. All right. I'm gonna be honest. I'm so sorry. I played this before and we did okay. Yeah, I mean, can't we just all just resign at this point? People are leaving because we're doing so badly at this. And also, like, for Pete's sake, are you kidding me? I can't hit anybody. I did just resign. Okay, your party was defeated. Okay. Well, that was a failure. I'm gonna go from now. Let's just log right out of there. I'm sorry. That was on me for trying an experimental build and being new to the format. I'm gonna go. I'm gonna go. Sorry. I'm gonna just log out. We're gonna do character select. And, yeah. That's about what I expected. I shouldn't have done an experimental build. It worked out pretty well last time, but I think the last time I used that build, it was a different type of build. So this time it was supposed to be, I don't know, the build that I was using has different, everything works differently in PvE, so that's what I didn't know. So here, for example, this has a recharge time of 1, 3, and 2. And if I do the guild hall, then I have the PvP skills, and it has 1, 6, and 6. So because of that, I can't do the same rotation that I was used to, and I just didn't pay attention to that when I went into PvP with a new build that I hadn't tried before in PvP. That was fundamentally bad on my part. The bow build would have been a lot better there. Oops. Oh well. It's okay. Like, maybe later. Like, the thing is, I'm not actually new to the game. Again, I've got like, what is this? 27, 46 hours over the past 58 minutes. But I think in some sense, like, I just don't do PvP enough because I'm terrified of it. Like, it's fun, but also, like, the problem with this game is that you have a lot of people that are kind of a bit elitist, you know? And so they tend to be, like, if you do something wrong, like, I've had people, like, send me whispers and being like, hey, you suck at the game, you should quit, and all this kind of stuff. And it's very, like, there's some toxic level there. I was kind of hoping that since people haven't been playing the game as much recently, that there would be less toxicity, and there probably is. But I kind of have a bit of PTSD, and I'm a bit afraid of hitting that, you know? So, we got some Balthazar faction for that. Let's see, what do we have here? I think if we do factions rewards, anyway, let me see, what do we have here? Also, I don't know, I just get a bit worried about it. I was gonna do tournament? No. Oop, what happened there? Hello. Interesting. Oh, that's interesting. Oh, well, okay. Let's just do this. If I press Alt and then right click, it gets all confused. Which sucks because Alt and right click is something you press a lot. Like, for example, if I'm looking for people, I'll press Alt to flag the name. So I guess I need to start moving and then press Alt is what I need to do. Doing it on stream doesn't help either. Yeah, that's also true. Ah, for Pete's sake. This is hard. Because the stream key bindings do something different than what I'm expecting. Also, why is she constantly strafing left? I'm not pressing any buttons. Yeah, she's constantly moving left now. Okay, there we go. The favorite thing about Guild Wars is the build system. Like, again, you can just make stupid builds and they're fun to play. And that's, like, for example, this bow thing that I had before. Is it good? No. Is it fun? Yes. And that's kind of like my philosophy with the game. It doesn't have to be good as long as it's fun. And that's kind of what I do with almost all of my builds. They're not good builds, but they're fun builds, you know? I'm going to try and do something else really quick. I'm going to go to Codex Arena. And I'm just going to see if there's anybody playing this game type. This game type, in principle, is my favorite, but I've never actually found anyone to actually play it. So I don't know. But essentially, what this one does is it gives you a set rotation of skills that you're allowed to use. And you have to choose from those skills. So you have a much smaller set of skills. So it's like, again, you're building your deck, but you have a few select cards to choose from. How long have you been playing Guild Wars? I've been playing Guild Wars. Let me check. Age. I've been playing Guild Wars for 158 months, which is Julia 158 divided by 12, 13 years. 14 years, actually, closer to 14. So basically, since Nightfall came out, I've been playing the game, which is the last full campaign. Let me just see what happens if I add some henchmen, and we just try. So I'm going to add support, I'm going to add frontline, and I'm going to add stone, right? And then let's see what builds we have available. So I'm going to just do K here, and what skills do we have to choose from? We have, we're going to have to do some sort of, oh, there's nothing good here. So we have this guy, and this guy, and this guy. We could do a Beast Mastery build. Hear me out. Disrupting Lunge. Let's see what happens if we do Beast Mastery. Alright, so we have Marksmanship. You got me beat. I stopped playing like 6 years ago and just logged back in. Yeah, it's one of those games that, like, I keep coming back to because it's super fun to play. I love doing cheesy Beast Mastery builds in Random Arena. Look, it's not a good idea to do it, but I will probably do it. So we need... Oh, but we don't have Comfort Animal. We only have Charm Animal. So that means we probably don't want to do that build. Let's see, what else do we have? We've got, Assassin, Critical Strikes, Dagger Mastery. We don't have a full rotation in Dagger Mastery, Deadly Arts, but we do if we add in Deadly Arts. So Stealth, 10 health. Stealth steals 10 health if the attack hits. What else do we have? We have Disrupting Stab. Yeah, this isn't really good for a rotation. We should try just going full Paragon. Okay, so we're going to do this guy, And then what do we have for Spear Mastery? So we've got Spear of Redemption. This build is really bad, but I don't think anyone's actually playing, so I think that's okay. And we're just going to drop down a bit here, go into Spear Mastery, 9, and then in Motivation as well. I'm going to drop here and then go there, and maybe add some more in Spear Mastery. Favorite profession is definitely the Paragon. And let's just see what happens. So we're going to do, I've got Song of Restoration. This build sucks tremendously, but we'll just see what happens. Removes 1 enchantment for each hex on target foe. That's not useful. Crippled. So this one does 15 damage, inflicts deep wound condition with a critical hit. That's kind of useless because I'm probably not going to get a critical because I don't have my little critical thing. That one's okay. Deals 18 damage, inflicts deep wound if target has more health. I could probably use that one. Mighty Throw. Okay, let's go. Because no one's gonna be here, so it doesn't matter. I can just like queue for this for ages because there's absolutely no one else playing this game, in this mission. But in principle, I really like the idea of Codex Arena because like it's, constantly like you just have a new set of skills that you build every day, and so you have like kind of a new like you can play the game at least once a day. And in my opinion, playing the game is like making new builds and seeing how things work together and trying new like crazy tactics, and that's kind of the thing that I really enjoy about the game. Again though, there's literally no one else online, and also like I need to mess around with this a bit. Let me maybe move that down just a hair. Maybe there's someone in another district? Let me see. Where I usually have the district down below. So let's try moving this around a bit while we're waiting on it loading. I can move everything up just a hair. Move this over here and move this up a little bit. That should do. Yeah, that'll do. Almost. Oh, it's bugging me. It's bugging me a bit. Okay, let's move this up just a hair. And then this up just a little bit. And this up a little bit. Sorry, guys. And that up just a little bit. So the end game of Guild Wars is literally just moving your UI around. That's what I've proven today. Because I've done nothing on stream. But I'm interested here. If you guys want me to do more like gaming streams, I'm happy to do another gaming stream. Again, we'll probably just do more missions in Guild Wars and stuff like that. It's just we started kind of late today, so I wasn't able to get through the full mission, and I accidentally canceled out. I think that's, again, pressing Alt and then left-clicking does something different than what it's supposed to do in-game. So I've got to remember that. I have to move and then press Alt. Oh, no, that still doesn't work. So if I do Alt, how do I make this work? So if I already have my mouse down, so I have to click my mouse and then press Alt. Okay, got it. Nope, for Pete's sake, I suck at this. Maybe we'll get back into Guild Wars. Yeah, that'd be, I really enjoy the game. I've been enjoying it a lot recently, and I thought people would also enjoy it here on stream. But yeah, it looks like we're not going to get anyone. We can try random arenas. Yeah, there's probably some people around in random arenas. Let's see what happens if we go there. Well, wait. Maybe? Come on. Try it one more time. No, okay. Let's go to random arenas. And let's see. So we do have people waiting around. But my build sucks. I don't really have a good PvP build, honestly, for the Paragon. I could try my bow build. But it has no healing. Which is again why I usually use that echo for healing. So probably what I'd want to do if I were to use this bow build, I'd load that, I'd move this out, I would use, probably want to use Signet of Return. Probably going to try Signet of Return. And then I'm going to probably remove, the issue here is that this is a 4-second recharge. So like my whole build dies when you have a 4-second recharge. So that's just not going to work. That's okay. So I think I'd have to try a fundamentally new build for PvP. It's just there aren't too many people that play PvP anymore, so it's not something that a lot of people do. Anyway, I think I'm gonna go ahead and go for today. I don't know. Maybe I won't do any more Guild Wars streams. I might just play it on my own. And maybe we won't do any more streams on it. Like on the one hand, I like the idea of playing the game and getting people invested in it and like really like making the game something that people play again because it is super fun and I think a lot of people would enjoy playing it, even though it is an old game, right? I mean, like you see RuneScape, for example, and RuneScape, like it's popular again. People play the game again. And is RuneScape fun? I guess it was never really fun for me, but maybe it's obviously fun for a lot of people. And like old school RuneScape, old school WoW, all this type of stuff got really popular, but Guild Wars didn't. And so I feel like it was one of those things I really wish it did get popular because in my opinion, it just blows the other games out of the water, but it just never really caught on, you know, for the people who were trying to you know, get into like retro gaming and stuff like that. So I might do it again, maybe not soon. I'm probably going to do more writing streams if I do more of the non-technical content. But again, if you guys are interested, I could consider playing more. I just haven't really decided what I want to do. So I'm going to go ahead and close for now. Let's see, who's actually live that we want to raid at the end of stream. So we have, let's see. We've got Jamie Pine live, Skylius, Caitlin V3, Tyanui, Tail Foundry. Let's see. Anybody they want to raid in particular? Enjoy watching, keep coding. Maybe I'll codex value next time. We could do Begotten X. Oh, if you want. Yeah, we could do, yeah, let's do that. He's doing Guild Wars. So let's go start the raid on, I don't even remember who this guy is. If I'm remembering, but let's do XB got in X. Okay, invalid username, raid XBegotten X. XBegotten X. Okay, there we go. Thank you guys so much for coming in. Have a wonderful day, night, afternoon, morning, evening, whatever time it happens to be your time. And I will see you guys around next time for the next episode of Simuleos. Again, if you want to see more gaming content, just let me know. I'm definitely keen to do more. I'm not much of a gaming streamer, so I don't really know. I'm going to be live tomorrow. We'll finish up the Convolution chapter, and we can go from there. So thanks, guys, and I'll see you next time. Bye, guys.